Howdy folks, how's everybody doing? Let me just jump in here. Hey Pancake King, how are you doing? Hope you're fine. And Rosalo, welcome as well. Just a late night stream, just checking around a little bit with code here. Nothing too sophisticated, nothing too complicated or anything like that. Do I want to work on the Airframe Manager or do I want to work on some failures? Let's work on the Airframe Manager. It's going to be done. It's not really all that great fun. Kind of hello everyone. Your print. Yes, indeed. A little cold furnace went out. Yikes. Yeah, that sucks in the winter. Hope you can get folks to fix that. Or somehow something happened to get that fixed. Yeah. There's a heating. I guess you're using natural gas then to heat your house or something like that. Lucky that it isn't quite winter yet, but yeah, yikes. Well, it depends on where you are, I guess. But again, yeah, for just thinking, you know, folks that are up in Canada, to them it's probably being around freezing point is still considered pretty normal, pretty good, nothing too bad. Okay, so yeah, I'm assuming that you responded to me that the audio is working well. By Pancake, but it's 3C here. Oh, yikes! Yeah, that's chilly. Very chill. Okay, yeah, that's even worse. We're this morning here as well. Yeah, it ain't that cold here yet, but it's probably gonna get there. You have to scrape the windows on a car. Ugh. That means it's cold and moist, which is the worst combination, I guess. So what did I want to do here? Right, I wanted to actually plan what I'm gonna fly as well later on. I had something planned out. I wanted to go Glacier Park, to Glacier Park, that's fun. I want to do this on Pilot Edge, or did I want to do this on as a pilot, the edge of pilots? I guess I'm gonna fly on Pilot Edge. We'll see. And there was an airport here that I had picked for an origin. Could have been North Bend, going from North Bend, or there was one that had an interesting departure. KUG. UG. Did. Okay, not that one. I'm basically trying to avoid like boring departures like this, because that's just fly runway heading to vectors. Yeah, so that's kind of whatever. Yeah, well, that might be interesting because that's gonna have a bunch of, well, not really actually. It's even more boring. It's just depart, turn, and then we'll figure out something from there. Okay, so it must have been. Oh yeah, Metford. Metford is the one MFR. I think it was the one that I was looking at. That one had sort of an interesting departure. Yeah, there's a little bit, with a little bit more pizzazz. Might have been a different spot. I don't know. I'll figure it out once I get to like the flying part or something. Patrona, sure, Billings, whatever. We'll figure it out. More importantly, get the Airframe Manager implemented. So the airplane is going to have the ability, obviously, same as the TBM, to have multiple airframes for you to, I guess, keep track of or whatever. They're not necessarily going to be tied to any particular livery. I was thinking about that, or there was some possibility for doing that. Not convinced that that's a good way to do it. The frost for me, I just wanted to warm up the car so the seats were warm when I got in. Okay, yeah, that's all good. Of course, if your car is equipped, they have like these remote heaters which you can turn on, and keep the seats for you before you even get to the car. You can turn it off from like your phone or something. Pretty nice, I guess. Fairly energy intensive, and you gotta have a complicated system in the car, not the aircraft, the car, to get that going. But whatever. Mine's manual, so you have to actually sit down and turn it on. Bit of aggression from the previous car with a remote start. Oh, okay, yeah. Why would you go to a manual after that? After having like a good, oh, I don't know, whatever. Personally, I don't really care for cars all that much, so from my point, my opinion on this really doesn't matter. Not a huge deal though. I try to park in the garage when it's actually winter. I like shifting, I guess. Okay, I mean, sure. To each their own. I'm not going to dictate what you can and can't like, obviously. Like that is definitely not my place to call that. Just notice there's a stream going on. Yes, Alec246. That's just a quick impromptu development stream and kind of stuff. Messing about with stuff. So, state file saving. There's a bunch of state files that we want to preserve and to serialize them correctly so that they are kept for each airframe. It's kind of a bolt-on feature on a TBM, and so for this I want to organize things a little bit better. So there's 3 files largely that I need to preserve. State.bin, the stuff in here in ABUS, and then the stuff in here avionics and VRAM. Yes, avionics and VRAM. Let's see. That's gonna be needing cuts into ABUS itself, this and this, and actually state.bin is selected in here, so that's easy to move. That's only a single file. ABUS, I'm going to have to play around with a little bit, and the avionics, specifically on the NVRAM, is going to have some modifications done to it. Yeah, we'll see. If I ever move to a populated area, I'll be getting an automatic through traffic and a manual. Yeah, it's pretty annoying there. Notice there's a string going on. Cool, I already read that. Cool. So, state.bin. What I want is I want a per blah blah blah. What's this crap? Okay, it's just some standard settings. And so what we want to do here is we want to grab and here create a little variable. It's going to be a char, and it's going to be the airframe ID or something like that. No, let's call it UUID. And it's going to be a 32 character pile of junk, and state save callback. And so what I'm going to do here is I'll duplicate you out of there and grab you out of there. This is going to be calling state save, and I want to create an abstraction here. So void state save. Now it's going to take a name for, let me think. That's going to take the name of a state subdirectory. So state name, right on, right? And it's going to pass a null state name. This is going to be a void state save const char state name. Neat. So we don't have a user info in here anymore. Good. In case we've not initialized yet, blah, blah, blah. We don't want to be saving state, good stuff. State create conf create empty, then we serialize the junk, and we can keep her save. Sure, we don't need this anymore. And so here's the tricky part, or here's the smart part that's going to happen. So put our little thinking hats on. If we do have a state file name, or if we do have a UUID, so if UUID 0 is not a null character, which indicated it's empty, then what we want to do is we'll grab the UUID, stick it in there as part of path component. So it's going to be, instead of explain, output CL650, the UUID of the airframe. And then if we have You want to put in one more abstraction here. Is state name is not null, then also going to put in the state name, UUID, blah, 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 actually. So it's going to be states, or rather, we're going to call this saved states. Just states. State name, state.bin, okay, good. Then, if we do not have a name there, it's just going to go to that root directory. And otherwise, if we don't have a UUID at all, which is we're operating in a stateless mode, then it's just going to grab and stick the state into the top level directory there. Cool. Okay, that's kind of starting to make sense. Let's see. Abus serialize. What do you take actually in here? Abus source abus.h abus serialize. You are taking a prefix for what's going to be put in there. I'll figure some of the stuff out later for the APU, ECU persistence, and blah 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 blah, or whatever. And actually, I am pretty much happy with this for the time being. I'm gonna path out the PL21 NVRAM crap a little bit later. Actually, PL21 init. So where do you go? You're in avionics NVRAM. Okay, so the NVRAM path here needs to be abstracted away. Right. Avionics NVRAM. Blah blah blah. Sure, whatever. The state restored. Does it restore? Are we going to restore the NVRAM contents as well? For the time being, probably no. I'm going to say no for now. Might need to do a little more disk IO to get that all in. Yeah, for the time being, I'm not. And if we have a UUID, not 0, then that's going to come in here. So it's going to be CL650 UUID, avionics, and VRAM, else. And VRAM is just going to be the avionics and VRAM crap. That's good this way. Yeah, sure. The reason why I'm basically separating out the directories that it's going to be storing the crap in, it's basically this and this. These two files, and they're for two separate things. Let me just think here. Yeah. So for the avionics and VRAM stuff, this is basically persisted NVRAM contents of the avionics modules. That'll be for things when you power down the airplane. This is what's going to reread back to figure out what it had done. So I can actually show you what these look like. They're basically just ginormous text files. Are they actually text files? They might be gzip compressed. Okay, they are gzip compressed. So if you go zless, you'll see that they look like this. And what this is just certain data contents of certain data structures are just stored in here in either big blobs or this is the flight plan content, so that's pretty large. But for any of the other componentry stuff like your settings and defaults and that kind of stuff, that's stored by the FMCs in their non-volatile memory, non-volatile random access memory, NVRAM. Kind of obvious. Plane is screaming. The plane is screaming. How is a plane screaming? What do you mean? Or is your, like the one you're flying right now is screaming? Which I wouldn't understand because you're a pancake, so that kind of be expected. Any plane's going to be screaming in your presence. Your little terminal thing. Oh, right, that. Yeah, it's just a bunch of ahs. Yeah. Yeah. This actually means 0. So this is 0 bytes. Anyway. Being a little naughty, I read the bug listed in the background. Engine torque effect on the airframe. How would you simulate that on a jet? Just curious. Do I have that in here? Oh, there it is. So the engine torque effects on the airframe, generally in flight, in normal operations, they are negligible. They're there, but they are fairly weak. But they are significant if you do get a locked up rotor. So if one of the rotors locks up for whatever reason, suddenly decelerates, that deceleration happens because it essentially has to give its rotational momentum to the rest of the airframe. Basically gets stuck on something, either usually a bent shaft or this is your broken bearing, a bearing that has essentially disassembled itself, and that can actually give you a significant rotational moment on the aircraft. So that's something I got to do. Anyway, FMC and VRAM, good stuff. I can basically, yank you over in one direction. But we'll see. I haven't done that yet. So. Let's see. So that's that. That's the NVRAM contents. Now that does not describe what you get restored. This is only used on avionics boot up, basically. The actual state, the runtime state, give you a little tug. Hey, Hawker Driver, how are you? Welcome. Howdy, everyone, indeed. And so the actual aircraft state is stored in this state.bin, and that's essentially the in-memory state of all the avionics modules and all the system modules in the aircraft. That includes all switch positions, all engine simulation parameters, everything is stored in this giant state.bin file. And it looks like a binary file, but it's actually, so if I just go ahead and less it, they're gonna even let me? Yeah, sure. It looks like a binary pile of junk, but really it's, again, another one of those gzip compressed text files. And this, what you see here, is binary blob data out of the state of all the avionics buses. Two soft tacos. Oh, cool. Life is indeed good then. So for example, this is the status of all the data. Well, the data buses, in this case, this would be specifically AP1 bus, CFMS1 bus, FCP1, FCP2, FDCU-1, and this is all the data that was on the bus as the airplane was serialized. And you can see there's sometimes quite a bit of data to be restored. And these are all the data labels for the data words that were currently on the bus at the time of storing. It basically preserves all the data as it was in flight in between avionics modules. And FMC sometimes do send out fairly large blobs of data. This is probably a serialized flight plan. This is probably another serialized flight plan. I could look at the exact definitions of what these contain. So for example, LFMC word 0, what would that be? I think are they just sequential? I'd have to look at the exact contents of the thing, but the actual data is in there. Yeah, they're just sequentially counted, so I'd have to look at what the exact data was in there. So it gets fairly complicated to read this by hand. You really can't, but the airplane can make sense of this. And this essentially allows you to restore this state of the aircraft anywhere. Even contains things like the position of the aircraft. So pause, I think lat or something like that. And where's the position stored? State save. State save. Fizz serialized, so that's under Fizz, I'm pretty sure. Pause. Fizz serialize. And there we go, position, and it's stored in Fizz geo, lat, and long and stuff. So this is your position at the time the save state was created. Lat, long, elevation, lat, long, elevation in meters above, I'm trying to think here, this might actually be geopotential height. position in OpenGL space, heading, pitch, the exact rotation quaternion that you had. Then you've got your velocities in local space. If you were moving that, this would be showing, you know, more than 0 values essentially. And then when you restore the aircraft, we'll basically chuck you into this exact state. In fact, I'm trying to remember here. I might need to store. Oh no, we do store PQR parameters. Here are your, I think they're the roll, pitch, and yaw rates. So we also restore your rates. And although X-Plane isn't quite perfect in restoring the atmospheric flow around the aircraft if you just move it quickly, it's generally close enough to where you'll be able to maintain control. It's going to probably shimmy about a little bit immediately after restore for a couple of seconds, and it'll sort itself out. But yeah, that's what we restore if you want it. Anyway, coming back over here. Let's go into all this stuff. So we do select which file we want to store. And more importantly, thank here. All right, yes. What I want to do here is also, instead of having an external state save, we also want to do a set UUID function here. Const chart UUID, const chart get UUID void. And so what these are going to allow is they're going to allow the Airframe manager to know which state you've got currently loaded in. That's some Windows crap. I don't really care about that. Wait, what I'm going to do is I'm not going to put it here. I'm going to put it state save and right next to this where the UUID crap is going to go. You initialize or let you save and restore everything on the aircraft. So return UUID. Also assert UUID is, well, actually we're going to let you pass a null there. UUID is not null. Otherwise, we'll go memset the UUID. Hang on, UUID. That's going to be the global UUID. There we go. Glob UUID. Glob UUID. Set UUID. Cool stuff. And we're going to go memset the glob UUID to 0. Size off glob UUID. And I think I have an init function. Yeah, I do. Paths init. Good stuff. And we want to make sure when you call set UUID that we are not initialized yet, because that would be bad if you did that while we are initialized, basically running as well. So that's not going to be there. Or that's basically going to make sure that nothing bad is going to happen there. And otherwise, we're going to string L copy UUID from UUID, size off glob UUID. And just for checking's sake, assert 3u, string length of if UUID is not null. Actually, I'm just going to put that in there. Assert 3u, 3 unsigned. String length of the UUID is less than capacity of this thing, so we can actually fit it in there. Good stuff. Otherwise, that'll be kind of bad. You could keep track of our UUIDs. Actually, probably even better. I'm gonna just make this a constant. So UUID len is gonna be, just call it UUID max length is 32 characters. Yeah, okay. Glob UUID, and that's going to be UUID max len. And inside of the aircraft manager, that's going to be also, there's some UUIDs over here. So UUID max length. Cool. And so the way that this works, it looks horrible at first, but there's actually some you know, reason to all this madness. The reason is that when you create a new airframe, let me show you actually a mock-up of the UI. So this is pretty much what it's going to look like in at least you know, once you're inside the simulator. It's going to pop up a window like this, and And yes, it's basically organized chaos. Stand by, let me just check something here. Nope. So the way it works is you're going to have basically a selector here to select which airframe you want to fly. And for each airframe, we track the you can either, it's going to by default load the latest state, or if you want to load a specific other state that you might have saved manually before that, it'll let you do that as well. The airframes that are stored on here, each of them is going to have its own set of saved states if you want that, or you can just apply the latest one that you have there. Hey Pilsner, welcome. And because I want to let you rename your airframes, you know, what if you don't want this one to be called MyJet, but you want to call it, I don't know, GBOAC or whatever. We can't store the data for, you can't store the data for the airframe underneath the name in the file system, because that would just mean I'd have to rename folders, and it gets messy, basically. So instead, each of these airframes, when you create a new one, it's going to get an invisible UUID assigned to it, a big long string of unique characters that looks something like, you know, something like that. So there's going to be a bunch of characters that you don't really need. There's no structure to them. They're just random bytes, but they are chosen to be unique. That's kind of the name. That's kind of why it's called a UUID, right? It's called a universally unique identifier. So this is supposed to be a unique thing, and then underneath here, you're going to have a directory that's going to be named this, and underneath that's going to be storing all the data about that particular airframe, or rather the state file anyway. So that's why UUID. What's up, HD? Talker driver, indeed. Coming out of Google Docs. That's good. That's good. Google Docs be docs. Anyway, so that's that, and then you've got your registration number. By default, I generate the reg number to be an NFA compliant N number, but you can set it to whatever you want. So it's just going to assign an automatically generated FAA N number. We make it a Canadian, I guess, reg, since it is a Canadian airframe, Canadian made. So I guess I could rewrite this to generate Canadian registry names. If anybody, what is the Pilsner, who can find me the Canadian, I guess, registry format, I can code that in, or I can just leave it FAA and just, you know, you can rename it to whatever you want later on, you know, once it's generated. So with this out of the way, I also want a function in here. So there's going to be a generate a particular airframe, AFM manager, load airframe. And it's going to take a unsigned number for the airframe, and then it's going to also take a state name, and we're going to also take a parameter called restore position. Easy CFXXX or CFCGXXX. Okay, and are there any particular characters out of those three that are not allowed? As for instance, in the American format, there are the characters I and O are not allowed in the trailing letters. Oh, expletives, yeah, sure, but those, we're very unlikely to really generate those. Then again, I mean, it's not impossible, I guess. And wouldn't it be funny if we generated something like C fuck or something like that? That'd be funny, personally. I don't know. Not that I know of. I'll check. Thank you. That'd be helpful. Yeah, sure. Make me some more tea. Thank you. Yeah, just order more tea. So, I could swap it. Let me just know. I can make it such that, I don't know, it could auto generate certain formats based on where you are located. That's a thing we could do. That's just for fun. Really just kind of a kind of a kind of a later thing we can play around with. So I wanted to put in that reg get reg, and then I also want to have a void AFM manager count states, and it's going to take the airframe number and const char AFM manager get state name, and that's going to be the number, and I'm going to make these a little bit more obvious. It's going to be airframe number, or the airframe index, really. So index, not just a number, but it's specifically the index in the list. Bfuck's a beaver, of course. Huh. Not that I know of. Okay. Well, at least they've got some fun with. Interesting that they allowed that reg, but sure, why not? So index and then state index, and this is going to be airframe index state. So it's not going to be state name, it's going to be state index, so state IDX. Good, and then bool restore position. Good stuff. So count states, get state name. These are the functions I still got to implement here. The new airframe just generates a new one. Count airframes. Then we want the airframe index in here. This is just making sure that we got the correct thingy there. Good stuff. Also airframe airframe index. So we've counted the number of airframes. Oh, this is airframe editing. I don't want that to be here. I want this to be here. Stuff. And then we'll want to go and count states, get state name. Sure. Count airframes. Good stuff. This is me just, building the back end to drive that UI, or rather what the UI there is going to be driving. Count states, so AFM index is less than list count airframe manager airframes. And for that, we're going to go const AFM T AFM. AFM is list get I airframe manager airframes, and we're going to grab the airframe index. And we're just going to go ahead and return list count airframe AFM, and we want to return the number of states. It was CFUCK, perhaps. Good, and then we're also going to go and do this. So then next one, check the state index is less than airframe counter airframe states. And it's going to be const AFM state T state. Status list get I out of the airframe states state index. And we're going to return the state name, which is stored in here. Cool. And that actually is going to be a file name. So if we make up our little test structure here, it's going to basically look something like this. It's going to make dir this directory, and then inside of there, it's going to have a states subdirectory, and then let's say we're going to create a state file, state directory called foo, and inside of all of that, there's going to be a file called state.bin. So it's going to look something like this. You're going to go into, so it's going to be in, where are you? There's going to be a state file, state UUID. And here is going to be a state subdirectory, foo, and state.bin. And actually at the top level here, there's also going to be a state.bin, which is going to be your latest state. So that one's always going to be outside of there, not inside here, because these are going to be depending on what you enter into that UI there. Yes, delete everything inside. Fortunately, I'm not getting that reg on any search. Oh well. Well, we're not going to constrain you what you can type in there. I mean, for whatever I care, you can just type in your, I don't know, your name in there if you want. I'm not really going to limit you to anything. Well, I am going to limit you to only characters that are legal, which is to say, let me think here. I think the only things that are legal in there are Latin letters, digits, and a single dash. Yeah, that's essentially it. Single dash is what ICAO specifies should be an airplane registration number. Post the link to general from the search site. Cool. Thank you. So, perfect stuff. So we got the state names recovered there. Found planes with CA. Oh, don't they have CFA through Z? Interesting. So that would indicate that there's no restriction for any characters. Well, at least that means that in Canada you can have 17,000 planes registered under C-F and C-G. So there's going to be twice as many. So max 35,000 aircraft registered inside of those two blocks. There's not a whole heck of a lot, to be honest. In the US, you would have the possibility. So in the US, you can have legal registrations are N, 3-digit 2 letters, or 4 digits 1 letter, or 5 digits, and anything sub 100 is not allowed. Also only for ultralights, yeah. And anything from 1 through 99 is strictly FAA internal use. So in the US, you can have, let me think. So you can have 900 for the first 3-letter block. So it's going to be 900 times 2 letters are not allowed. So it's going to be 24 to the power of 2. That's for the first set. Then you can also have 9,900 times 24 plus 99900 times, and that's it. You know, that's for the 5-letter versions. In the US, you can have a total of 855,900 airplanes registered inside of the N number registry. That's the max it can support in its current layout. So there's your upper bound, I guess, if you want to know. And theoretically, I mean, they could probably just add a digit or add a letter. It would be more spatially efficient, although definitely not easier to read, if they were using all characters. So if they were like N and then 5 letters, that'd be much more efficient. Although it would be a little bit difficult to figure out, so it'd probably have to go like N dash, 4 letters, and that point 24 to the power of, if they were allowed to use all 4, that would give them another 500,000 aircraft registrations. With 5, that'd be 11 million, or yeah, 11 point, almost 12 million. Like 75%. You can also do 3 digits and with only 1 letter if you want, but I don't do research on my own age, so well, that's not what the FAA website suggested I found. We go to N number format FAA, format N number, and this is what they say. It's going to be 1 to 5 numbers, or 4 numbers but with 1 letter, or 3 numbers, or 1 to 3 numbers, I guess, but it's really 3 numbers. There's CL650 in Brazil, and I'm telling you how its model is officially spelled. The model ALEC 246 is CL60. Rosalo, it's Yes, theoretically 1 to 4 numbers, but the numbers may not start with a 0. Yeah, I guess, but registration numbers N1 through 99 are strictly reserved for FAA internal use, and you may not start with a 0, so N01 is not legal. So realistically, you have to go at least like that. And I guess that means you also need 2 letters. There are regs that are fewer than 5 characters in the US, but I think new ones have to have 5. Yeah, they might have been omitted. Yeah, so RJB 4000, I think those are like legacy registrations. They get traded for huge amounts of money. I remember Max had their Cirrus registered November 5 Mike Whiskey or something like that. And they paid, okay, and they paid huge amounts of money for this. And they paid, I don't remember exactly the number, but it was like in the tens of thousands of dollars just to get a short reg on their aircraft. How to start investing in tail numbers, yeah. There's a Bonanza of November 5 Kilo is similar for sale recently. Yeah, and that one's going to go for a huge amount of money just for the tail number so they can actually scrap the aircraft and reassign the tail number to something else. Anyway, well, that's what the FAA says. That's probably for new registrations. For old ones, they can, you can probably find old crap, but for new stuff, I don't think you're going to be getting away with that. And since, well, theoretically, you can buy a new aircraft and put an old tail number on it, but whatever. I'm not going to get into that. Cool. So what did I want to do here? The 1 of 4 is what I read and stopped searching at that point. Right, I see. Actually 1 to 5 if you want to get really, really technical. You can have 5 digits. Cool. Actually, what did I want to do here? That reg. Right, so load airframes, airframe index, state index, restore position. I do have, what do I have? I've got the state name returning. Get reg, set reg. New airframe function is here. I'm gonna move you down so that it's roughly in sequence with how it appears in the header file. And now for the state restore, that's going to be a bit of a delicate ballet to get it to work correctly. Yes, so November 1 Alpha 1s. Yeah, MJJCYC, welcome to the stream. It's probably like legacy N numbers that are being traded for, massive amounts of money. Real zone isn't allowed in the UK once it's been used, it's done. So no G-Bulk. Yeah. Well, there you go. CAA as usual, ruining the fun for everybody. List get airframe manager, airframes, and we're going to grab the airframe index. Seems like they may run out of regs eventually. Well, I think I just there's a Goodyear airship. Oh, well, those guys are all about promotion, aren't they? So I could imagine that they paid huge amounts of money for that. Pancake King, the number of registrations possible in the US, I guess. So it's probably a little bit more than this, but not that much more. This was sort of, I'd say this is the lower bound of the maximum number of possible registrations. If you round it up to 1 million, I would say that we're comfortably within all the possible formats that are allowable. In fact, I can, let's see. So if we make this 1,000, not that, we make this 1,000. make that 10,000, make this 100,000, and we'll include an additional block of 1,000 times 24. That would give you all the possibilities that are shortened with only a single letter. So this would give you all possibilities of like 5 Mike whiskey. This is going to give you all possibilities of like 5 Mike, so November 5 Mike or whatever. And yeah, this is essentially the max number. So if I'm going to go, if I didn't account for something, it's probably going to be a fairly small block. And I would say 1 million aircraft and no more. 1 million registrations possible in the US and no more. So I guess they're either going to have to reuse disused ones, or they have to change the format. You're actually, Reflect Reality Sim, that's actually going to be an interesting problem in the UK, because there are not all that many possibilities. Well, there's 500,000 possibilities in the UK for letter only registrations. So if you go G and then 4 letters, arbitrary letters, that's 26 to the power 4, this many. And if no repeats are allowed, so say for instance, you could do like, I don't think you actually can, right? So you could theoretically do this. This should be allowed, so I guess that would be a legal one as well. So this would really then be just short of 500,000 possible. I guess once the UK has manufactured 500,000 airplanes, it's just they're going to be shutting down the entire industry. Or by that time, the math classes pay off, I guess. Or I guess by that time they'll change the laws on the books and allow reuse of registration numbers. Cool. So what if you don't have a state index? So if state index is not UN32 max, then we're going to also fetch a particular state. So const afm state.t state is going to be, well, not going to just explicitly initialize it, else state is null. We'll only have 2 airports by then anyway. Perhaps, yeah. You periodically download the whole Canadian registration database and check for free tape. Pilsner. You madman. Yes, I could theoretically, but gotta. Okay, so I'll want a state save, and then I'm gonna have a state load here, and it's gonna be const char UUID. Actually, even better. We can go ahead and leave the get UUID here. It's gonna be fine. I'm gonna grab a state load const char state name. Realize I'm not allowed to talk since I'm a US citizen, but we are talking about the UK and legal mumbo jumbo here. The och and fucht FUCT are taken sadly. What about CFUKT? Or maybe that? I think this one will be better. Would this work? CFC fucked. That's a little bit cryptic. Isn't quite as obvious. Anyway. Enough messing about like a little kid. So this is state save here. I'm gonna go and get rid of this, set UUID, and I'm gonna put a state load function here. For this, I'm going to assert that we have been initialized, because that is going to do the reinitialization for me. We're going to assert that a UUID isn't actually necessary. It actually isn't. So, I'm eternally 12 years old. Same. So yeah. Take FAA rules over CA rules at any point. Okay, so state load, and actually it also needs the restore position flag here. Full restore position. And so we'll do a bit of a naughty thing here. Do we actually need to pause the simulator for this? Theoretically, we don't. So we won't. Good stuff. So, what we're gonna do here is I'm gonna go and do a eggs plugin disable. That sounds weird. Like, what's happening there? And so this is basically going to be performing a soft reinitialization of the plugin. So it's going to disable itself, then enable itself. This isn't actually running any kind of code for X-Plane. All this does is it's calling my own disable and enable functions or callbacks inside of my own code here. X plugin disable. It's only calling my own plugin callback functions, and so that's it, essentially doing like a soft reload of my state of my code, my own functionality. So put our little thinking hats here. So the way that the restore is going to work is it's going to do an X plugin disable. It's going to copy over the UUID of what we're going to be doing here. So if UUID is not null, then we'll copy over glob UUID, string length, glob UUID. Actually, not that. It's going to be a size off that UUID. And then it's going to be if we have a state name that we want to restore, then we'll also copy that over. So glob state name, and that's going to be glob UUID and glob state name. And I'm actually going to make this another constant here. So state name len or state name max, just whatever, that's close enough. And also it's going to be in here, state name max. We don't accidentally try and use a file name that is too long. Glob state name and state name max. Okay, load state. What did I want to do here? Save state. State load. Yeah, right. Noun then verb. Sometimes I can't make up my mind whether I want to name things name verb or noun verb. Then sometimes I do verb noun. Yeah, I should one of these days probably figure that out. So glob state name, and it's going to grab size off glob state name. And the reason why it's storing these here rather than using them right away is because the restore, the positional restore, is going to be done at a later date or at a later point. Once the X plugin enable runs, it'll re-enable the flight loop processing, and then on the first flight loop iteration is when we actually do the state restore. Otherwise, memset glob state name 0 size off glob state name, so it's just going to zero it out. But this will cause the restore of the default state or the last state. And also glob state whatever static bool glob restore position. For now I'm going to put it default to false. Glob state name glob, not global. Glob is close enough. And otherwise, if we don't have a UUID, we're just going to zero them out completely. And for checking purposes, I'm also going to check if you passed a null UUID, you must have also passed a null state name, because that would be invalid if you were trying to load a state from a non-named airframe. And also in this case, we are going to go glob restore position is going to be restore position. And here I'm going to go assert not restore position. Glob restore position is going to be false. So if you've not initialized anything there, that's going to do that. Good. We're looking at the time here. How about we go flying somewhere? I'm going to just quickly dash all of this crap. Otherwise it's going to fork itself, because I didn't really check anything for this to actually be able to function. I'm going to quickly recompile. I'm going to do a bathroom break. And actually, we're going to not fly online. It's a little bit too much hassle to fly on Pilot Edge this kind of an hour. It's a little bit too late for me mentally. So, code. Oh, I want to go flying with you guys. Let me check if Goran has some stuff for me to play around with. Not yet. Let me ask him. Do ELLX to Lowy and suffer another humiliation on Discord, where I'm going to be called out for how badly I flew into Innsbruck. Although I have not flown from Luxembourg. Cool. ELLX to Lowy. Oh, long flight. Be doable. It would definitely give us somewhat variety, because we'd be arriving at Lowy from the west, which means we could try some RNAV stuff and fun. Do like one of these RNAVs here. I'm gonna ask for a deep explanation about someone just starting to learn C++. Gonna use IDE to try to learn, or try to learn as you do. It really makes no difference. People get too hung up on it. Alec 246. If people just get too hung up on it and trying to figure out, you basically, the tools do not matter as much as the basic knowledge behind it. So the more important thing is, not whether you're going to be using an IDE or not. It's more a matter of like learning the concepts. So I don't think I've ever seen someone fly the RNAVs into 08. Well, we could. Is there weather there? There is quite a bit of weather. Broken 1400. Winds out of the south, so no specific runway preferred. Would actually be preferable if we flew in from the west here, because that's coming in over the valley, not over the city, because the city's over to the east of the airport. The city's right about there. So it'd be preferential at this time of day to be coming in. Well, I mean, the airport's closed at this time of day, really. It's past midnight there. I'm doing the Loc 08. Loc 08. Well, there is no Loc 08. There's a Loc 26. Is there a Loc 0? Oh, I guess theoretically. What the hell is this thing? Well, certainly not after sundown. But I guess this would be something you could do if we were coming in on a conventional nav. An RNAV 08 the other day. It was pretty nice approach. Yes, it is. And there are two different ones. There is this one, which is a straight line version of this one, which supports curvy stuff. And since this part here is too short for a final approach course, initial descent, caught out, A340s, LNAV, VNAV. Interesting. Yeah, ends in circling. Yeah, I just saw that, but you're not going to be doing this after sundown. I mean, I could fly during the day, so it wouldn't make a difference, but yeah, this would be interesting, to say the least. But anyway, so interesting detail on this. You'll notice it goes into a thick line here, and then a dashed line on further out. And the reason is because they don't have enough room in the valley here to extend the final approach course to a sufficient length. Nobody does that now. Yeah, make some spaghetti with the nav path. Oh, always fun to have spaghetti. And so since they don't have enough room here to extend the final approach course for a proper, straight in intercept and down the final approach course, I'm not sure what the minimum is, but it's probably like 4 or 5 miles you need at least on an RNAV approach. So instead what they did is they basically made this the final approach course into Whiskey India 814, and over here, this is your misapproach point, and you're supposed to disconnect the autopilot, and you can use the flight management system for guidance, but the autopilot's not allowed to fly this, and you're essentially visually navigating from here. So not quite. Actually, it is visual. Yeah, it is visual because this is your landing minimum descent altitude 7,100. You're gonna be 5,200 feet above field elevation to actually get there. So RMPAR to the rescue. And here you'll notice it's solid all the way through the runway. And that means this is allowed to be flown coupled on the instruments and on the autopilot. And for that, you need actually curved approach support in the FMS, but it is going to give you only 1,000 foot minimums above the field. So that's a lot better. But you need approval for this. And what's the final RMP requirement? 0.3. Okay, that's pretty normal. That's what we can do. To do the RMP Yankee on autopilot, it has to be visual. Yes. Yes. I mean, yeah, you could do this, but from here on out, this is your misapproach point, and you're supposed to be visual past this. I guess you could fly theoretically on autopilot, but yeah, the minimum here is definitely VFR day weather. You're not doing this in bad weather at all, which currently it is bad weather there. It's broken 1,400 of a field elevation, so this one will be no good today. You probably have to fly the localizer 2.6, and then, well, you couldn't even circle, right? Because it's past sundown, so circling to 0.8 is out of the question. So you'd be straight in 2.6, and if you have too much tailwind, it's a diversion. Hey, greetings from Scotland. Welcome, Langers. 1987. Welcome aboard. Anyway, sure. LLX to ELLX to Lowy. So let's plan that up. Go to sim brief. Actually, I'm going to start loading in the sim as well. I'm going to clear the state files that I have in there. Airplane's rebuilt. So let's go ahead and get this thing firing up. Good stuff. So I want to go dispatch. Create a new flight plan, sure. Cool. So we want to go ELLX to Lowy. And we're going to take my little Challenger here. Boop, boop, boop. Don't need any of that. Take what flight plan? Wow, that's a lot of waypoints. That is one crooked path. Gotta love European Airways. But at least we had to have fun with it, huh? Sure, let's do that. So I'm going to take you into the sim. More than I had. Yeah. So let's go and take this thing full screen. Select ELLX. And where are we going to park here? This looks fairly general aviation-y over here. Or maybe this. Let me check if they have a good chart on Navigraph. What I had. Huh. Interesting. Yes, plus Met. That's the so this looks is probably the terminal. This looks fairly GA. What are those programs you use in the background, my friend? I'm not sure which programs you mean. And I'm gonna just stick it over here. This looks fairly GA type kind of deal. And I want to select real weather. Cool. Rock and roll. Got the Challenger selected here. Let's go. Make it a daytime flight because nighttime's kind of boring. Cool. So for the time being, I'm gonna. What was all the text? Well, Langers, I'm a software developer, and I was working on the airplane here, coding, and now we're gonna go for a little bit of a flight in it. But yeah, that was basically just my work in progress stuff. Cool. I'm gonna let the airplane load here, and I'm gonna take a quick step away from the machine for bathroom break. So you know, 5 minutes, folks. Quick bathroom break. If you got them, you know, smoke them if you got them, as they say. Talk to you in a couple minutes. See you later, Alex 246. Here we are in the airplane, and we're facing the wrong way. Oh, this is a cargo ramp. Okay then. Well, let's have a look at where there's not a cargo ramp. Okay, so G is going to be over there. Cool. I'll just quickly reposition and customize, and we're going to go up and whatever, somewhere here. Let's go. Linux is the name of the program. Yeah, it's all cargo over there, just as you said. Heard about Linux, but never used it. What's an operating system, Langers? Well then, leading edge. I mean, feel free to push it through. I'll reload the airplane. Far west side, I reckons. That is indeed correct. Did I crash myself? Yes, I did. Ah. Okay, well, something I gotta fix. Stand by. For just one sec here. Get way people forget. Okie doke. Really about give me 1 minute to make sure everything is covered. Don't worry, leading edge. I can reload it and while I'm still here on the ground. So there's absolutely no need to hurry or anything like that. It's just me sort of playing around, toying around with the idea. But I know you want to show off the good work you've done in the cabin. Yeah, folks, the cabin is taking shape. And yeah, Warren here has basically, I would say not quite finished all the modeling, but almost all the modeling is finished. At this point, that we're basically just wrapping up texturing. So we do have landing gear finished. We got wings finished. We get basically all the 3D parts. The shape of things is finished. It's just a matter of like getting the nice models textured up. But yeah, so that'll wait for a little bit. And let's go ahead. I think I do have sounds on, don't I? For the sim. Yeah, hopefully I do. Let me see. Yes, I am developing an aircraft for X-plane Langers. Exactly right. Let's see, why isn't it generating noise? Well, it should be now. Oh, right, I've got that turned down in here, don't I? Ah, there we go. That'll make it make noise. There we go. That's what I wanted to hear. Haven't seen that long ago. I was last year. Brett Live, welcome. Commodore Challenger 650. Will the HUD be modeled too? Yes, Matthew. It's implemented. I'm just waiting for Gordon to like give me. Gordon's going to be doing that as part of finishing up the ceiling here. Exterior check. Oh, John, that's going to be coming a little bit later. But yes, most beautiful business jet ever. That it is. We're also going to have that, you'll see the striking livery they're going to have also as well. We're just barely fitting on here on this ramp. We're going to pull the airplane back a little bit because the airplane placement on the ramp here is a little bit off. Wouldn't be. I hate it. X-plane's positioning code. See, I'm pulling down and it's pulling me up. Like, how do you mess that up, X-plane? There we go. That's better. I'll fly the shit out of this thing when it comes out. Can't wait. Oh yeah. We would have loved to release for CTP, but unfortunately, it would have been unfinished if we did. So it requires a magic touch. Not the only one with that problem. Beautiful landing gear. Yes, sir. Yeah, Pilot John is. Let's just say Gordon has gone a little bit overboard on the detail, and it's not just nuts and bolts. He's gone to the point where he's modeled the lock wiring. So you can check if the lock wire is present. Cool. Okay. For the time being, I'm just going to quickly pop open the door here, for which I still got to do the sounds. Let's go ahead and pull you down. Nuts and bolts and wires. Yes, sir. Doors open just for the time being. Sweet. And what I also want to do here is, so before we fire up the APU, you always, before you do anything with and that involves burning fuel, you can also check an AC is going to be depowered, DC is powered, batteries are good. Before you do anything that involves burning fuel, you always want to make sure that your fire suppression system is functional. So test the engine fire bottles. Whips are continuous, good. That means you would be able to extinguish fires. And we'll also check the fire detection.
Jet pipe overheat.
So we were looking for five fires here.
Jet pipe overheat.
Is it too
Jet
loud?
pipe
Let me check.
overheat. Jet pipe
It
overheat.
isn't. Good. So we're looking for 5 fires here. There are 2 fire loops per engine and 1 for the APU. So that's why you've got 5 messages here. 1 for the jet pipe in each engine, 1 for the engine core, and then 1 for the APU. And we also check for the portion of the aviation roll, and this in Dassault Falcon, yeah. And then we're also looking for 5 fail messages here. If I pull this back, this checks for if the failed loop detector is working correctly. So that is good. You guys doing the same maintenance wear hub for the TBM? Not quite, Pilot John. It's going to be similar, or the daily tasks that a pilot needs to check are going to be there, but we're not going to break it down into individual components because that would be just a little bit overboard for a Challenger. Cool. So with these 4 switches operated, we know that we're going to be able to detect fire, or we're going to be able to detect fires, or we're going to be able to extinguish them or put them out. So with that in, or that out of the way, go ahead and push this. Going to give us the APU ECU is fired up, and push that in, and the APU is going to start spooling. Alrighty, and you might have noticed, you can hear actually the blades are clanking here. Yeah, as the engine is freewheeling in the air. So APU generator is off, so we're going to go ahead and put that guy on. I'll take my hat off to you developers. We're so hard to bring us every best detail there. Yes, sounds are alone already. Oh, I must have pay airplanes so far. Well, glad you like them. So with that out of the way, APU generator on bus. Got to give us volts and frequency, and the rest of the avionics is going to fire up. And for that, we'll also check that we've got good AC volts. We want to check that the hockey stick, they call it, is not here anymore. So if I go ahead and depower the APU generator, you'll see it gives you this kind of a look here. So where the APU battery is powering the APU battery direct bus, that's normal. But the main battery is also powering the battery bus. And if we had, we operated one of the switches here, if I operated the ADG deploy, then it would also power the essential bus. This is called a hockey stick. So normally the batteries during, of course the connects call it hockey stick. Of course they would. So once the APU generator is on bus, it actually disconnects the batteries, and the essential and battery buses are going to be powered by the essential TRUs, the transformer rectifier units, which are the things that bring AC power, because this is an AC generator. The AC generator connects to the AC network, or like this, and powers AC bus 1 and 2. And off of these guys, you've got the transformer rectifiers, TRUs, and they are powered off the AC bus 1 and 2, and off of the AC essential bus is this guy here. Now this is a very, very simplified layout. What'd you call it? A rifle? So it's a very, very simplified layout. If you want, of course, you've seen me do this a number of times. You can go in here into the study menu, go in under electrical network. You're going to be able to see it in a lot more detail on what's going on and where stuff is happening. So if we want to bring it up in a little bit more detail, here's the APU generator, the APEPC contactor. Does look more like a rifle to me. The APU, the auxiliary power, external power contactor, APEPC, which then goes to a crossbar, goes to the generator transfer contactors, and those then go on and on to the generator line contactors, so GLC1, GLC2, which then feed the respective AC bus 1, AC bus 2, and each one of these buses then has a feed through. This is a three-phase circuit breaker, so these are actually three electrical phases, individually AC phases. That then feeds through to from both AC bus 1 and 2. And there's an AC essential bus transfer contactor, which goes up, 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 up into another contactor called the emergency AC transfer contactor, which then actually feeds the AC essential bus. So if I bring this up here, you'll notice this is a very, very simplified layout. Just goes like line, line, line. You don't care how you get there. But there's a fairly tortuous path and quite a number of things that have to be switched correctly before you get like power on the AC essential bus. That electricity needs to feed through quite a bit of switching logic before it goes there. And so what happens, for example, when I depower the APU generator here, when I put the switch off, the APU generator control unit, the GCU, there's a little control unit in here that does this. So it flips the APEPC contactor to center, basically, and this is the normally open position, so it's basically nothing. Flips the generator transfer contactors to the transfer state, which is the normally open position, and also depowers the generator line contactors. So none of the AC network is powered at all. Flip this open, or flip this on again, and everything comes back to life. And you'll notice we go off to here. There's a device hanging off of the AC bus, main battery charger, but more importantly, love how the lines light up when powered. Yeah, and they light up with the power source. So if I was gonna go ahead and call up the external power unit, let that one roll up to power. So that guy's powered on. We got the the field, and we got the avail light up here. And if I go ahead and I got to depower the APU generator for this to transfer over, because the priority goes to the APU generator, you'll notice, sweet, new seats pushed, lovely stuff. You'll notice now it's cyan instead of yellow. So now it's powered by the external AC generator. I swap the APU generator back on. Goes back to yellow. And the left engine is red, and right engine is green. Funnily enough, I don't even remember if I did this on purpose, but this actually corresponds to the nav light positions. The position lighting is red on the left, green on the right. So I guess this kind of gives you an extra indication of which side of the aircraft. There's a math refresher too. Oh yeah, we do simulate the actual math going on inside of there. So you're going to look at the exact amount of power that is feeding through. So for example, we've got 115 volts here, 400 hertz. There's 33 amps flowing through from the APU generator, or 3.8 kilowatts. Goes through here, 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 and you'll notice 28 amps here. This is actually, so 33 amps is because that's essentially the efficiency of the generator being taken into account. So the generator, and it's a little bit more of a notional here, it's not really 33 amps, it's the equivalent of 33 amps is what the load is on the generator. Will be enough to almost qualify someone for a 650 engineer, perhaps. We'll see. Sort of thing, how I learn the best doing things with detailed diagrams showing what's happening behind the scenes. Yeah, so this is the actual, so you'll notice that this says 33 amps. Why does it say 28 amps here? The rest of the math out there. Yeah. Why does it say a different number here than here, even though there is nowhere else for the electricity to go? And the reason is this is basically the electrical load, so to speak, or the mechanical load on the generator, because the generator is not 100% efficient, right? So it's 84% efficient currently, and it changes with the amount of load and the amount of RPMs that it's doing. So this is essentially the amount of energy that it takes mechanically off the APU, and this is the actual amount of electricity that it's delivering, 28 amps. And if we follow it down, obviously this should now split, right? We shouldn't see here the same amount of current, and we don't. This is feeding 19 amps. This is taking 8.7 amps, or 1 kilowatt. This one's taking 2.2 kilowatts, and it's because there's different componentry on here that is feeding stuff. That's probably a good or primary reason probably why this is taking more amps than this, or more power, is because this is currently feeding the AC bus. And the AC bus is eating 1.5 kilowatts of power. So what would happen if I transferred the AC bus? I can do that. I can tell the aircraft, you can see there's an empty line here, and actually feed through the AC bus from AC bus 2. And to do that, you've got a AC essential bus transfer. This guy here. If you push this, it'll take this contactor and swap it over to the other side. And now this side is consuming 600 watts, and now this side is consuming 2.5 kilowatts. So now the power to feed the AC essential bus, it's still consuming the same amount of power, but it's now feeding through a different path to it. And off of these guys, you've got, if we go down here, we've got the transformer rectifier units, and that's the symbol for a transformer. So it's a rectifier really, but it takes AC power and it rectifies it into DC. So alternating current into direct current. And so out of here, we've got in 115 volts, 400 hertz, 5.3 amps, and out of there we get 28 volts, 15 amps, 400 something watts. And you'll notice there's again a discrepancy. Written out that squiggle. Yes, sir. You'll notice there's a discrepancy again, 600 watts in, 420 watts out. And the reason is, again, a rectifier has a finite efficiency, right? You'd actually need these rectifiers. They sit in the nose of the aircraft, and they're the things that you hear primarily when you are when you come out to the airplane here. Obviously, if the airplane was like powered off like a part, you could actually hear if you open this up, and we're going to make it such that you can open this up, and rectifiers, the TRUs that are in here, and they have to have active fans cooling them, otherwise they overheat and they shut down. Okay, push this back in. We'll power up the AC and DC utilities. So these are these buses here, and they're what powers up the cabin stuff in the back. And actually, in that vein, I'm going to do this. I'm going to pull the latest changes. Hopefully my sim is not going to implode if I try and do a little bit of reloading the scenery or the aircraft. If by shutdown you mean smoke and attempt to catch fire, then yes. Well, yeah. They might actually, let me think. I think they might not shut down, but they will try to keep going, because obviously this is a critical aircraft system. So it's going to keep most aircraft systems, unlike in a car. I'll fix any seat issues if you see them. Any streams and aviation tutorial. Oh, glad you like them. Yeah. If you know anything about the design philosophy of aircraft, is most aircraft systems, unlike what you've got like in a car, they're not designed to protect the systems. They're designed to run to destruction because they might be critical. So something like a car engine, if the engine management unit detects a fault in the engine itself, it's going to try and shut down the engine, or you're going to get reduced power, something like that. Do you fly IRL? Langers, yes. I haven't been in the aircraft in over a year now because Corona, and it's expensive. But yes, I do have a private pilot's license. So I guess you might call me just a weekend warrior. So I'm not really, I'm not a commercial pilot by any means. So I'm just a weekend warrior. But yes, I do fly real aircraft. Anyway. Something like the engine on an aircraft, unlike in a car you're going to get reduced power, or it's just going to shut the car off to protect the engine, and so you can get the engine out to a service facility. On an aircraft, it's the opposite way around. The ECU, FADEC, or whatever you've got in, or even just a hydromechanical unit, it's going to keep running the engine until complete destruction if necessary, just to give you a couple of minutes of extra power, because it's a critical system. You need that for safety. Cool. Let me reload the aircraft and art here. Hopefully that's going to work. I bet you missed getting in the skies. Well, yeah. No limp mode when you need every... Yeah. That's the thing, is there's very little margin for error on an aircraft, so it's gonna run itself to destruction if necessary, just to keep you flying. So, folks, I haven't seen the new seats yet, so I guess we're all gonna be discovering this together. So, passenger doors open. Yeah, sure, I know. An aircraft has redundancies for safety, though, right? Not everything Langer's 1987 depends on the aircraft. So, for instance, like a single-engine Cessna only has one engine, right? So, no, it doesn't. It generally, the stuff that is most likely to fail, like things like small instrumentation stuff, they will have redundant, but no, not necessarily. It also depends on a lot of, categorization of the aircraft, on what parts they are, certified and stuff. Okay, so we got to do some realignment of the seats here. But yeah, some texturing little stuff here, or you might want to shift the seat a little bit forward. But yeah, it's looking pretty mint. Yeah, it's a work in progress. I understand. But yeah, it's turning into an aircraft, right? So we could actually, sit here and enjoy the ride at this point. Oh yeah, and the cushion. Oh my, the cushion. Just want to jump on and, feel how soft it is. We still haven't made the door here operable, but yeah, also got the nicely lacquered lav and everything. And I'm a vampire. I don't have a reflection. But yeah, this is how BizJets look. Love the cushions. Yeah, this is what BizJets look like. And so if I were standing at about, I'm 5'9", so it'd be about there. This is about what it would look like for me in eye line height, I guess. I'm looking at creating an interior paint kit. Yeah. Your mirrors reflecting the CV panels. LOL. Yeah, that's kind of a limitation of X-Plane. The issue is X-Plane doesn't actually support ray tracing. To get a fully oblique, reflection of what is behind the camera, you'd have to have ray tracing. And that means essentially, that's not an X-Plane. And it's probably going to get added in XP12 later on, but it's not there yet. Oblique reflections, X-Plane could do via screen space. Might not be able to own a real life pictures. I got one in a virtual world. RTX on. Yeah, indeed. So, so many streams lately. We're spoiled. Well, manual, aux override. Welcome. And yeah, it's getting close. Even got the toilet paper here. That's lovely. And a little wooden holder. So, that stuff. Get the door out of the way. But yeah, and Gordon was just working on these fat, chunky seats. These are what Bombardier calls the nuage seats, the cloud seats, because they like fold out and do all kinds of funky stuff. We'll get this texturing on the window here sorted out later. It's a little bit off, but yeah. But yes, Jack, hope you're doing well. The plane certainly seems to be. Yes, sir. And of course, you got the privacy door here and that stuff. And it's about the only door you've got to, I guess, block off the cockpit. Because there ain't no door here. Ain't no door to the cockpit. There's a curtain that you could pull over, and that's about it. Anyway, enough dicking about it. Barely powered up the airplane. I've been talking for half an hour. Cool. So we got the airplane power up, and let's go ahead and get this stuff on the road. So let's get the flight compartment checklist out of the way.
Flight compartment checklist. AC and DC electrics.
Are checked.
Nav lights, logo light.
So nav light's gonna come on. Logo we don't need during the day.
Cockpit lights.
Are set.
Lamp test.
Lamp test. We'll go ahead and do lamp test 1, and then lamp test 2, and also you could do it looking like there, and look at this. Cool. Those glass textures still are neat. Would be awesome to have that on the windscreen as well. Maybe the windshield we find frequently, though the reflections are a little bit distracting. We'll see. About a 6 year in like 2 weeks. I'm gonna be putting in some serious hours and getting things finished and fixed. Yep, myself as well. Cool. Cockpit lights and lamp test was done.
Duct monitor.
Duct monitor is up over here, so we're looking for a duct monitor test.
Bleed air duct.
Loop A test, loop B test.
FMS database status.
I'll check the FMS database. That's index, status, cycle through, and cycle through again. Get the current one. Will the talking checklist come with the aircraft? Yes, it will. Well, actually, it's going to be a little bit more sophisticated. It's also going to give you hints on what you want to do. In fact, the checklist is customizable if you want it.
FMS flight plan uplink. ATIS.
So we'll go ahead and grab the flight plan here from SimBrief. I am bin number 650. Do that in ATIS. I'm actually just going to go ahead and grab data link weather. So I've got a weather terminal request ELLX. Send. Very cool to see project coming along near the end. Thank you for both sharing development. Well, I'm glad we could.
Anti-skid.
Initiate it. So anti-skid. Tested.
Nose door.
Yes, also want to make sure it's armed. Nose door is clear.
Hydraulic 3A pump.
Goes like this. This is data link, so we got the data link weather. Hydraulic 3A pump is on.
Brake pressure.
It's checked.
Parking brake.
We'll set the parking brake here. Looking for parking brake on.
Nose door.
Nose door is closed. We don't have a red nose door message anymore. The bug coming. Your next agreeable between both of us. That's a time thing. Your filler work. Yeah. The nose door, I can actually show you what that looks like. I don't have the switch currently on the airplane there, but it will be. If I pull the manual gear release, you'll hear what it looks or what it sounds like. That actually opens up the nose door on the aircraft fully. And after a little bit.
Nose door.
So if you had the nose door open for servicing and stuff, you'd have this message on there. So, and that closes the nose door. I just stalled an 8340 while on autopilot in normal law. Oh, that's a little bit jank. Got an animated dose. Well, I forgot a lot of stuff as well about what I had already done on the airplane. It's
Hydraulic
closed.
panel and pumps.
Hydraulic panel pumps. So on, or auto.
Electric panel.
Electric panel is checked.
AC DC utility switch.
It's on.
Start ignition panel.
Checked.
Fuel panel.
Double smiley test. 1, 2, 3. Green for green, green, white, white. Turn this one on. This goes out. So swap over. We're still running. Push. This goes on. Close, close, close. Everything goes out, and we get yellow and up. Good.
APU LCV.
APU LCV is up here.
10th stage isolation valve.
This guy.
Packs.
So turn on left pack. And you'll see the APU get loaded down with the pack load. As the pack fires up and starts taking off bleed air off the APU temperature is going to come up. You can tell he started this thing more than a few times. Yeah.
Air conditioning panel.
Yay. Actually, I'm going to keep this up here so you can see. Air conditioning panel down here. We'll transfer temperature over for the cabin to the cabin.
Pressurization panel.
Press panel. So we'll land 2,000 feet is elevation of Innsbruck, and the rest is actually for the time being. So we've got the weather here. It's just going to quickly peek in here. 1001 is the QNH. So I'm just going to bring up here, and we're going to go 1001. And since the pressurization can only be set in inches, I'm just going to go 1001 and read the value off here to 29056. So I'm going to set this guy over to 29 or about there. Maybe like that, 295 something. The CL650 pod here. Hey, how are you? Welcome, man. Cool. Press panel is set. We can also check that the fault lamp here works. Good stuff, and all the other stuff. I'm happy. We don't have the emer depress, and we're not on manual control. Good stuff.
Bleed air panel.
Bleed air panel. I'm happy with the way that it is.
Supplemental ground wing anti-ice panel switch.
Is out. We don't want the off button
Cal
on here.
anti-ice switches.
Owl. Oh, they're off.
Anti-ice panel.
Go to the detector test, and then the wing overheat test.
Wing overheat.
Good stuff. We also check for, make it like this. We're also checking for that we got
Wing
these
overheat.
the test OK indication
Wing
here.
overheat.
We also got the left and right
Wing
heat
overheat.
lamps on as well. Sufficient heat. Can't stop thinking about the meme of the two Spider-Man pointing at each other when I hear the two Totos. Yeah, I guess. You're the mastermind behind the great Better Pushback. I am the guy who wrote Better Pushback. Would you call that a mastermind? I guess, sure.
Emergency lights.
Emer lights. Switch armed.
Passenger signs.
We'd actually on the first flight of the day, you'd also check the emer lights. So you do like this, check that you got an emer lights on, switch it off, goes away, arm, doesn't turn back on. Good. And I'm using Librain as default as well. Well, leading edge. So you're giving a little bit too much credit there. They have taken my code, basically re-implemented it in their own way. So there's really nothing of Librain left in XP12, but yeah, that's where they took their inspiration from. Cool. Passenger signs are on.
ELT.
Is armed.
Glare shield panel.
Glare shield is set. No unexpected lamps or stuff.
Crew and passenger oxygen.
So we got oxygen pressure 1920 psi. That's good. We don't got any oxygen related cast matches, which we wouldn't expect here. Test the left side is good. Test the right side here is good. We'll check that the oxygen switch is in normal. Therapeutic oxygen we can leave off.
DCU warning panel.
This, we want to make sure that these are guarded and not lit.
CBR.
Pull it in. Wait for the internal test. There we go. CBR tested.
Audio panels.
Audio panels, we're not going to be flying online, so it doesn't really matter where we got those set, but you want to make sure that you've got them set correctly to the settings you are looking for. You know, what you're talking on, what you're listening to, what you're talking on, and also, you know, the other stuff.
SPS system.
SPS system test would be down here. I'm just going to do a quick one. This is done only on a first flight of the day, but this is the first flight of the day, but I'm just going to do a quick test here. I'll just do a dual test for the pusher and shakers. So pusher is working, shakers are working, ignition AB is lit. If I go and push the AP disconnect, it goes away. Good stuff. Or the pusher releases anyway. Close enough.
Integrated standby instrument.
And my instrument is set,
Clock.
reset.
EFIS. ICAS.
EFIS and ICAS is explainable. Everything on here, we're not seeing anything out of the ordinary. No cross-out values, nothing like that.
Main landing gear bay overheat.
Come down here, do a main landing gear bay overheat test.
Gear bay overheat.
And a fail test on the loop. Good.
TOS warning switches.
I'm going to make sure those are covered, and we also do a toss test. So just hold it for a second. Let's going to do a quick toss test.
Wide slope. Pull up.
You hold it for more than
Wind shear. Wind shear.
I think 3 or 5 seconds. If you hold the switch for more than that,
Up.
it's going to do the full toss test. You hear that it's already done, and it's done with the toss test. So it's not going to, keep blabbing on. But if you hold it for like 5 seconds, it's going to give you the full message set, and that's going to take about a minute.
Pitch and roll disconnects.
Pitch and roll disconnects, you want to make sure those are in and stowed. And as I learned from CL650 pilot, many pilots usually well, he teaches them not to do it, but many CRJ pilots, they'll rest their palm on it and push down on it to make sure that they are fully in. But see those stickers on there? Those are glow in the dark, probably radium stickers. It costs like $5,000 a piece. So rubbing them off just by normal usage, not the smartest decision.
Ground spoilers.
Ground spoilers are an auto.
Thrust reversers.
We're coming to arm, and we're gonna get the 2 green lights. It is checked.
Thrust levers.
Thrust levers are checked and shut off.
Engine speed switches.
Engine speed switches are back here. I mean, they're self glow in the dark pancaking. They're probably something radioactive in there. Speed switches are on.
Engine vibration check.
Engine vibe check. Want to make sure that we got amber vibes on the fan and the N2s.
Oral warning.
Oral warning test is here.
Smoke detector.
Smoke detector test.
Smoke.
Few messages here.
Smoke.
Trims. Mock trim.
Trims. So we'll turn you on and mock trim also. And we want to make sure that we got no more trim messages, no stab channel 1 in up or something like that.
Yacht ampers.
Push that on. And if we had, say for instance, if one of the yacht ampers was an operator, if I push this in, we'll get rid of the amber cast message, but we'll get a white one at the bottom to inform you, and hey, the other yacht amper ain't active. It might be functional, but you didn't push the button in, or it might be dead.
Reversionary inhibit switches.
Reversionary inhibit switches is back here, so we want to make sure none of the 2 inhibits are pushed in. Norm. Depending on which side you're going to be flying from. If you're going to be flying from the right side, you probably want the ICAS on the right here, not the left. But that's that. Norm. Whichever AFCS you're going to be flying with. Usually flying with 1, but if you have an AFCS 1 fault, you can fly with number 2. And you're still fully Cat 2 capable on that. Norm. Good. IRS is aligned. We have no more message here telling us that we're aligning. We've got a valid heading. We can even verify that by going into index IRS control, and we've got a drift value indicated, or we could go to index posit it, and then we are given a position and a speed, so everything is fine. It's not giving us a time to nav, so that means the IRSs are no longer in alignment mode.
CPDLC.
We don't have CPDLC on here yet, but we will eventually.
TCAS.
First flight of the day, we do a TCAS test. So go to tune ATC, do a TCAS test there.
TCAS system test OK.
ATIS and clearance.
So ATIS and clearance, we go ahead and pick those up.
FMS flight plan. Wind update. Perf.
Okay, so we finally gotten to the point where we go and fetch our flight plans. So go to flight plan, sec flight plan, or even if you went to the route menu, there's a shortcut here to the sec flight plan. That's where the data link loads the flight plan. It goes into the secondary flight plan first, and for some reason it is fetching the wrong flight plan for Henderson to OTH. Definitely not the right one. Did I not actually confirm this in brief briefing? I didn't. So to that end, good that I checked. I gotta actually confirm it on SimBrief. Today I learned it's fairly normal for corporate pilots to change seats, so PF's always on the left seat. Yes, I learned today as well. So apparently in the company that CL650 pilot is in, they always fly from the left seat. And since they're pretty much all of them are captain qualified, they always fly from the left apparently. I guess that simplifies things a little bit, but sure. So, since this is not the right flight plan, we got to go back to route menu, flight plan recall, go ahead and send. And we'll wait for a new flight plan to be fetched via the data link system. At this point, we can just go ahead and admire waiting for the flight plan to get downloaded. Yeah, there it is, already downlinked. Cool. So go to sec flight plan here, ELLX to Lowy. That's what we expect. We can go ahead and check it against our filing here. So GTQ looks good. UN852 last sat. I'm pretty sure it's the right thing. It looks pretty much what we are looking for. LMAM is nice because that's going to give us a straight approach into transition into the approach. Cool. So I'm going to go activate the flight plan, execute the flight plan. Now so far it's only, it doesn't have a SID because that you got to select your own. You're on your own. You would do that based on whatever your weather is and whatever they give you on a clearance. We're winds out of the southwest here, and we already have, I think, a runway selected. Or it's already given us a runway to fly from, which I think is runway 24. We'll go to DEP-R, depart arrive, runway 24, and GTQ-1 X-ray is what I saw on the flight plan there. Actually, GTQ-1 Yankees is what they want me to fly. Now we're gonna fly the X-ray. What does that look like on charts? SID GTQ-1 X-ray. That doesn't have a whole heck of a lot of chutzpah to it, but we'll use what we got. So this is the preferred runway anyway currently. So let's go with that. So go to back to legs, and I'll check that they are all linked up correctly. So GTQ pull well, and then it continues on. No discos. That's good. Execute. So next I gotta go in and initialize the flight altitude. So that's, you notice currently it's not giving me any predicted altitude levels here. It's just giving me dashes, and these are just coded constraints as recognized by the fact that they are in large font, not in small font. Small font stuff will be predicted. Large font is coded stuff, or basically constraints. So to get the predictions in, we got to give it a target flight altitude. I'm gonna go to flight level 390. The flight plan wants me to go to 410. That's stupid. No, not on such a short route. I'm gonna go flight level 39. Actually, I'm gonna give it. We've got 9,200 pounds in the tanks here as well. And now, if I go to legs, you'll see it's calculated the vertical path now for us. And it's given us also a descent into our destination, which is lovely. So I'm going to execute that. But you'll notice we don't have any wind data yet. So to do that, we're going to go into flight plan, route menu, flight plan wind update, and we're going to go ahead and fetch that over data link. And all that is there. I'm going to say that we've programmed the flight plan, we've requested winds, we've done the perf. So
Takeoff data.
Takeoff data. Go to perf menu, or hit it again. Perf menu, takeoff data. And in here, I'm just going to copy in the data I have on the weather data. So external temps is +6. Unit, it automatically picks up from the EFIS, so that's fine. I can punch in the wind, so that's 230 at 6. Punch that in there. Cool, and it's going to give me predicted V speeds, or it's going to give me V speed computations. So I'm just going to click send, and that's going to get filled in here, and we are done. This takeoff data is confirmed. We got plenty of runway.
Avionics and charts.
Avionics. There's a whole procedure on how you're supposed to check everything on here. There's like a little spiral that you do. I'm not going to bother too much with that, so I'm just going to roll my speed here up to 200. Quick check. Do we have a speed restriction? Data link wing's updated. So if I go to here, leg wind, and now we have predicted winds at the altitude that we are going to be at. So I'm just going to go ahead and execute that. I'm happy. And just a quick check if we have any speed limitations. No, we don't. For charts, I'm just going to bring those charts up over here. Lovely stuff. All right, we're in daytime, so swap you over to day mode. And you'll notice it automatically picked the chart up for our departure, because I have Navigraph in here. So, what does the chart say for initial climb constraints? Blah, 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 0 top altitude. It requires a minimum climb gradient. Initial climb is 4,000. So roll the pre-selector up. We're looking for 4K here. 4,000 and also 200. So there's a whole procedure where you go like check that you've got the correct mode selected, and also I'm gonna set runway heading for now on the heading there. We'd go and check that we're navigating off FMS1 heading 230. We got the V speed set in here. You rattle those off. That that you got a speed constraint that's selected correctly, altitude constraint selected correctly. You got the correct QNH, and any modes, extra stuff that you want on here. I'm gonna have terrain on the pilot side. I'm got the rose mode on. I also got terrain over traffic overlay selected on. I'm offline, so it's not really gonna matter. Right seater would do the same, by the way. Cool. And avionics and charts now are set. Avionics is set.
Flight instruments.
I'll check that we've got correct indications that left and right are matched. You'd actually get a miscompare flag if the altitude was out of range. So yeah, that's all set.
Departure briefing.
Departure briefing. If we look on charts, fairly straightforward. Gonna be runway heading 238. Back to legs here. Runway heading 238 to Delta 238 Foxtrot. So it's the 238 radial off the Luxembourg VOR out to was the 6 miles. Yes, that's 6 miles because letter F means it's the 6th letter. Hey, Ruka. The chart's can be pulled up from the NFDs. Will this not have Avatab support? It will, Ruka. It will. We've already got that planned out. It's going to sit on either side of the pilot. So there will be Avatab support as well, of course. So Delta 238, so to a distance on the 238 radial off the Luxembourg VOR Foxtrot. Then a left turn to 116. And that is going to go off on the from the Luxembourg NDB on the 116 QDR out to a distance of Papa. Papa is what, like 20 miles or something? Or probably also, I don't know. We could, there's probably an RNAV overlay for this to be able to see what it's doing. Let me see if we can find that. Go to upper menu here. Roll the inner knob here. So if you just push select, that'll just show the chart. But if you roll the inner knob, it'll take you to the menu here. And there is not an RNAV overlay. Lovely stuff. I love that. Absolutely brilliant. No, GQ, that's all the RNAV information that we get. So presumably, I can confirm my plan here if I go to get rid of this overlay and go to plan mode and advance this guy back a little bit. Back. And just make sure it looks like what you expect it to. Yeah, there we go. Delta 216 Papa. And I'm going to get rid of the altitude displays here. It's a little bit annoying and in the way. GT27B, yeah. That's this guy here, 8,000 or above. $27B, yeah, right, because 27th letter, there's 26 letters in the alphabet, so it's basically rolled over to that, to the next letter. So it's B and then Delta 2 and Delta 335 Yankee. So that's coming in here. And that's this guy here. Yeah, its 25th letter is Yankee. 26th would be Zulu. Isn't it? Yeah, something like that. So, Delta 335 Yankee, and then Grosten Holstein Quinn, something like that, right? Then GTQ, and then our onward and upward, I guess, and the rest of our procedure. So, departure brief. I'm gonna call that complete.
Emergency procedures.
Emergency procedure. You know the drill. Just yell when everything's on fire. Otherwise, don't bother me with it.
Pins, covers, chocks.
So pins, I'm gonna shove in, and gonna tell them to take their AC generator and piss off from the airplane.
Cabin lights, water heaters, master seat.
Hit that one. Golf Tango Quebec. Yeah.
Flight compartment checklist complete. Engine start checklist next.
Cool. So go ahead and pack up the door here. I gotta finally get to, once we've got the most of the cabin in, I'm gonna work with Gordon on putting on all the manipulators for you to close the door nicely. So close that and shove the handle in. Airplane's closed up, so we're gonna get a little PAX door closed, green light, or green cast message. Sweet. And by the way, if you had, so there's a whole bunch of sensors on the door here that checks for all kinds of air conditions. So say for instance you forgot to shove the door handle in, the door is still locked, but you'll get an amber cast message that says passenger door outer handle is not pushed in. So, and if it's fully unlocked, then you're gonna get the red passenger door ding ding ding. So door's locked but not fully stowed on the door handle. There's actually even an interior door handle here, and it's like a little T-bar you'd pull. We're gonna put that in. When you pull that in, it pulls in the outer door handle, but then you also got to stow the inner T-bar. That's it's another cast message about that as well. So yeah, there's a whole truckload of cast messages just about the door. There's a bunch of sensors in them. Good stuff. So, let's get out of here. Frankly, been on the ground for forever. Cool.
Engine start checklist. Doors
Are closed.
Parking brake and pressure.
Parking brake is a set. Pressure
Checked and
is
set.
good.
Fuel quantity and balance.
Actually, there's a bunch of items that actually get auto-completed for me. So fuel quantity and balance, we're looking for within 400 pounds on the ground. We're good.
Beacon. On. Fuel boost pumps. On. Ignition.
What are we gonna do here? Whatever. We'll do
Armed.
today.
Engine 2 start.
Alrighty then. Push the button. Would you want to? One more thing. Before I do that, how about we do a start from the? Yeah, that's gonna be a fun one, right? That's perfectly safe to do. I've got the buttons bound up for it. We'll let this thing spool back down. Let's pretend we did a engine clearing run. And actually one more thing. Gotta go to tune here. We got some code set in. Sure, whatever, something like that. So I'm gonna let the engine fully run down, or nearly fully. Close as we are gonna get. Now let's do a startup here from the passenger seat, right? Just for funsies. You can hear the soundscape in the back. I think I got the sound up. So, got little pop-ups here for the overhead and stuff, so I'm gonna run that from there. So, right engine start. And we got 25%, we got N1 indicator, we got oil pressure less than 120 degrees ITT, so fuel in. Burn-in fuel, good stuff. And N2 is rising steadily. We got oil pressure still looking good.
Fuel system.
And the engine is stabilized, so we're looking for 20. So there's a 2464 or 2462, depending on whether you have kilograms or pounds selected here. So we're looking for 20-ish% on the N1, 400-ish degrees on the ITT. That's a little bit below that because it's fairly cold there. This is going to be about 400 degrees on a standard day. 60-ish% on the N2 at very low temperatures. Is actually going to be quite a bit lower, but yeah, 2, 4, 6, and roughly 400 pounds of gas being burned. Now these are sea level conditions, standard atmosphere. So as a pilot, you're going to learn that this is going to be lower on a cold day. This is going to be lower on a cold day. This is going to be higher on a high altitude airport. Same thing here, higher on a high altitude airport, and lower fuel obviously burned in the other cases. So fuel system check is done by turning off this pump here. That's going to switch both pumps off, and we are cancel this caution. We're looking for a low fuel left pressure. Good stuff. That means check valves are working fine. Put that back in.
Engine 1 start.
And we're going to do another start here, looking at the other engine. And I'm going to shove my head right up to the glass as far as I can. And we got more than 20% N2, less than 120, N1 indicating good oil pressure. Fills in. Light off. Good acceleration on the N2.
Engine start checklist complete. After start checklist, next.
Good, so 2, 4, 6, 400. The oil pressure is going to stabilize. This is a little bit, the oil pressure, when it's cold, when the oil is cold, it gets very viscous. And so when the oil pump is pumping, it actually generates a somewhat high oil pressure. That's going to go away once the oil heats up a little bit. You can see the other side's already fairly warm. But yeah, that's going to come down. A little bit of amber there is expected. It's allowed to go, I think, spike up to like 140 psi. Cool. After start checks.
After start checklist. Generator 1 and 2.
So I'm just gonna go quickly like
On,
so.
checked AC and DC.
We got good
Ignition.
volts there, and we got everything still powered here. Ignition.
Disarmed. Packs. On. 14th stage. Open. Cowl anti-ice.
And you do it. Switch on.
Check 45 seconds.
Turn
Flight
on the
controls.
timer here. What is that message again? Flight control, right? Yeah. Flight control test here. Come down. Do a full and free movement. So down, right, up, left. Looking good. So I'm basically looking for correct indications. Rudder, left, and right. Lovely stuff.
Ground spoilers.
Ground spoilers pulled back. No deployment on ground spoilers. Pull them into arm. Ground spoilers are going to deploy. Back to R. Back to auto. Just they're going to shove back in.
Flight spoilers.
Flight spoilers are back here, so they're going to full. So all 4 spoilers are going to deploy. Go to half. Half deployed and full ground spoilers. Those are only either fully out or fully in. And stow those. Everything goes away. Good stuff.
Cal anti-ice.
Now anti-ice. We've got the green message on here, so that's all good. Within 45 seconds.
Supplemental ground wing anti-ice.
I'm going to push the test on switch here.
Test on. Fuel balance.
Yes, check still within 400 pounds.
Trims.
Trim, so I'm going to set it for quickly for takeoff. There's a whole test procedure for testing both yokes and all the trim cutouts in that. Did somebody send you a nice set of expanded procedures? Maybe, reflector releasing, perhaps.
No steer.
No steer is going to come on.
Armed. APR.
APR test is over here, so we'll test forward. APR1 test OK. And test the other one. APR2 test OK.
ADG unit.
ADG unit test this back here. Goes out after 2 seconds. That's good.
Supplemental ground wing anti-ice.
So, we are looking for a test OK indication here within 2 minutes of the Cal anti-ice. There it is.
Cal anti-ice.
That is going to go off.
Off 14-stage isolation valve.
Yeah, I skipped an item there. Supposed to be wing anti-ice is going to go to norm. 14-stage isolation valve here. Push that in. Opens. Closes.
Wing anti-ice.
That is, we got 2 green lights here. And no errors. We got wing anti-ice in green. Good stuff.
Check.
Off.
Off. ATS.
ATS. So to get the ATS into takeoff mode, we have to mash toga here momentarily.
N1 TO. ATC TCAS.
So ATC TCAS. I'm gonna go into Alt on mode.
Alt on. After start checklist complete. Taxi checklist next.
Lovely stuff. So let's go ahead and push this thing into some actual. So first, in order to get the charts on the left side here, the charts are full screen only, and I can't do that with the ICAS on there. So what I'm going to do is, for taxi purposes, I'm just going to go and take this switch here, ICAS on both PFDs. I have some thoughts about the speed of the wing heating up during the test. Feel free to drop those to me or to the guys in the group. Perfect. So both PFDs. So I basically compressed the ICAS onto the left and right PFD. So now I have this thing fully available to myself. So I can go ahead and push charts here. That's going to give me the airport chart. And we're going to go to runway 24. It's a straightforward taxi over Alpha here. So nothing too complicated. Let's go. Check right and left. We're not going to run over anybody. Light on, brakes off. Let's go. Check my steering here. Steering is functional. Check the brakes here. Brakes are working. Good stuff. Nothing more to it. Get going. A little bit of power just to get rolling a little bit faster, but generally you don't have to give it power. Once you're rolling, the airplane will taxi usually and keep speed pretty well on idle. That's an interesting change of weather there. Thank you, X-Plane. So now the weather is actually correct to what we had planned for. Cool. And you know what? Since it's kind of cold-ish, it's +6 degrees, we should be doing a wing anti-ice and cowl anti-ice departure. So I'm going to switch those on here momentarily. Well, not the wing anti-ice, but the cowl anti-ice, yeah. And what you'll notice, if I do that, I'm going to bring the ICAS back over. So you can see the ITTs here. There's going to go up. And with that in, we are going to recompute the takeoff performance. So we are going to be taking off wing plus cowl. Send that in. Test those new leads. Yes, sir. Cool. Let's do the taxi checks. I'm going to switch you over like so.
Taxi checklist. Taxi lights. On. Wing and cowl anti-ice.
Is wing is currently off. Cowl is on.
Brakes and steering.
Checked.
Reverse thrust.
Do a quick reverse thrust test. Both reversers are deploying good, so that's done.
If taxiing the de-ice, pause checklist here until a paper de-ice checklist is complete. Flaps.
Flaps. We're gonna go
20.
for 20.
Altimeters. Set and cross-check. Radar weather. On. Takeoff briefing.
Is reviewed.
Taxi checklist complete. Before takeoff checklist next.
Alrighty, actually gonna take that back over to charts for the taxi purposes. Still rolling on alpha here. I'm gonna lower the yoke here so it's out of my way. That voice actor sounds familiar. Yeah, kinda. Might have heard him somewhere on TV, I guess. You see, I haven't added in power. We're still on idle, and we're going 24 knots, and actually it wants to still accelerate a little bit. So it will roll on its own usually. The actor's gonna pay royalties for every play. Yeah. Hopefully. So we're gonna take it all the way to the end of the runway. Although we actually don't need it, but sure, why not? Who does that? Yeah, Alpha 1. Yeah, sure, we're gonna be good. Sweet. So let's just go ahead and roll onto the runway here. You'll notice since we're moving, I don't really have to do much of anything with the actual operating of the aircraft, switching and that kind of stuff. So I'm just gonna go ahead and tell them to run the checklist.
Before takeoff checklist. Passenger signs. Advised on. Anti-collision light. On. Pros. On. Windshield heat. On. Wing and cowl anti-ice.
Wing anti-ice we're going to take to norm. I'm going to get rid of the chart here and switch my stuff like that.
Continuous ignition. On. ATC TCAS. TARA. Supplemental ground wing anti-ice panel. Checked. CAS. Takeoff config OK.
Yes, it is observed.
Landing, pulse, recog lights. On. Before takeoff checklist complete. After takeoff checklist next.
Sweet. Let's go. I'm gonna push toga here, and I'm gonna arm LNAV and VNAV. Both are indicated correctly. Let's go. For takeoff, we're looking for 88.2. So ATS on. I'll make this so that we can actually see it. And thrust is set. 80 knots. V1. Rotate. Just going to rotate into the pitch queue there. Positive rate gears coming up. LNAV and V pitch have engaged. And we're in IFR. I'm going to go select light level change here. At 1,000 feet, I'm going to go autopilot on to be able to use my hands here. Roll the speed up to 210. And we're already capturing or getting close to a capture, so let's go ahead and continue our climb. Light level change. Let's say up to flight level 130. Keep accelerating on the speed there. We're above target speed +5, so flaps are going to go up. No more over temp. Yeah. I reworked some of that. Cool. We can now go 250. I'm kind of driving it like a little bit of an idiot. You know, they drive the airplane a little bit more gently than I am, but whatever. So I've got only one joystick, you know, I don't have pedals on, I don't have proper yoga and stuff, so I'm just kind of picking my way through here. Anyway, so 250, we're climbing away, good stuff. I'm just going to go ahead and start the after takeoff checks.
After takeoff checklist. Landing gear. Up. Flaps. 0. Thrust reversers. Off. Ignition. Off. Pressurization. checked. Pax transition.
And it's now transition that bleeds over.
Completed. N1.
Whoa.
Climb
Still
set.
gotta just-
APU generator. Off. APU.
Still gotta adjust
Shutdown.
that.
Passenger signs.
Bleed flow a little bit. A bit too over temp happy. Passenger signs, I'm gonna leave until we're done maneuvering here.
CAS.
Is checked.
After takeoff checklist complete.
We should be clear, really. We're clear of the icing conditions, so wings are gonna go back to norm. And don't need the cowls either. I'm gonna put the ATS back in. Oh, strange that it's over temping quite so heavily. It shouldn't be. I'll have to check that. Oh well. And let's continue to climb here, why not? So, good, flight level change. Constraints wise, those are all just at or above, so not really applicable to us. Not really something that would concern us too much. And of course, I'm kind of being naughty here. I should have this over on the VNAV menu or VNAV display. And the right side should be on. Window on. There you go, though. Cool. Above 10,000. Actually, I could have turned off the landing lights quite a while ago. Out of speed 270. Yeah, that's the one we'll keep for the rest of the climb here. Why are you so misaligned? I have to have a chat with this guy. Good to know that that's actually going to upset it. This departure. Sweet. Also past transition here, so standard pressure. Standard pressure. Oh, the poor ISI, yeah. Have to have a bit of a chat with it about why it's so misaligned. It's pulling itself back slowly. So once we're in level flight, it'll realign itself. If you've got it, you know, you want to, you can manually cage it, and that'll pull it basically into level, fully level, and then it'll basically just try and reestablish a new attitude. Why don't you use VNAV? What do you mean? Why don't I use VNAV? I do. I am on VNAV currently. Like the FMS climb speeds. I can. There. They're the same as I was using anyway, but there you go. Yeah, there we go. Now it's magenta. There is a service bulletin for limitation on the airframe for not using FMS speeds or FMS speed control in Mach mode. I thought you had a reason. Yeah, there is some sort of a service bulletin. I can't tell you the exact reason. It might something just have to do with the real thing having certain corner case bugs, or there being some legalities. As it was explained to me recently, there are some pitfalls with certain UK airports and flying VNAV with the pre-selector selected above your first constraint here. Apparently, the UK CAA has a bit of a racket going. I would call it a racket, but they're probably going to say that they've got good reasons for that. They've got a bit of a racket going where they're going to look at your, so this pre-selector value here is actually transmitted on mode S transponder responses. So when an airborne radar or when a secondary surveillance radar interrogates the airplane over the transponder, it's the mode S transponder. What it does, it also responds with a bunch of meta information about you. So you don't only send out your transponder squawk code, you also send out things like tune here. You also send out things like your flight ID here, which and I have a letter from them to prove it. Yeah. So you also send out things like your flight ID, and among other things, you're sending out your pre-selected altitude. And so there's a bunch of constraints at or below coming out of I think it's Luton. Anyway, it's one of the airports in the UK that has a constraint on a SID of at or below 4,000. And then your final SID top altitude, your clearance limit, is 5,000. What the guys are gonna, if you have VNAV, the VNAV will respect a climb constraint, becoming more of an issue, it seems. I've heard several non-UK operators being called by ATC to ask about their selected altitude, same for EGKK. Yeah, so once I have VNAV enabled here, the airplane will stop at that 4,000 constraint, even if I have something higher rolled in here on the altitude preselector. But apparently in the UK, the CAA looks at the preselector, and before you actually exceeding 4,000, they'll already write you up, and they'll essentially violate you for haven't even selected anything higher than that 4,000 constraint, even though your aircraft avionics on VNAV is always going to stop at the constraint, even if you've got a higher altitude selected. Yeah, and so what we've kind of thought about this with Graham here is perhaps it is caused by Airbus I, because one of the pitfalls of the Airbus is, as long as you're in managed climb, it'll respect the constraint, but managed climb essentially gives you full rated power climb, right? So it'll basically go to the climb setting on the engine, and it'll just maintain the speed with pitch. That means the airplane's going to climb like a rocket ship, especially when it's light. What a lot of operators do is when they're approaching their select target altitude, what they'll do is they'll switch to vertical speed and roll it back to something like 1,500 or 1,000 feet per minute. And what that will cause is the Airbus at that point will disregard any VNAV constraints, and it'll just keep on climbing in vertical speed until it hits your pre-selector, your pre-selected altitude. The Challenger will not. You'll notice here it says VFLC, right? VNAV flight level change. That means it's respecting constraints. And when I go to vertical speed, it says VVS, VNAV vertical speed. So it still respects constraints. It will not bust a constraint, but an Airbus will. So I think, or at least we think, that maybe because they might have had busts from Airbuses, that they've instituted some sort of a preemptive violation to enforce everybody to pre-select their altitude selectors 1,000 feet lower on that 4,000 to, I don't know, work around something. Frankly, I have no idea. It's somewhat of a pitfall of Airbus automation design, I guess, but even there, I mean, Airbus pilots are smart enough to know how to fly their own airplanes, but, takes only a couple of idiots for them to screw it up for the rest of us. So it's coming to revert to VS and a final 2,000 for the climb. Apparently in the UK, they have gotten to the point where they're basically trying to punish pre-crime. Before you even committing the violation, they're going to already pre-fine you for the violation that you haven't actually yet committed, but might. They think they can read your mind, and they think that you're going to do it, even though they're on a Challenger. That is literally not going to happen. Because as long as you got VNAV in, it'll always respect it. It'll even do it if you are in complete pitch mode only. So this is now direct pitch control with the little wheel here, but you'll see it says still V pitch. That means the airplane will still respect constraints even in pitch select. Yeah, whatever. Cool. So, since we're on our way up here, Mach 0.77. Predicted top of climb here is just about Lassat there. We're not going to have much of a cruise here, maybe 50 miles in the cruise. So, and it's actually going to shorten up because we're going to fly by Lassat by quite a bit. So it's actually going to cut the corner by a good chunk. Yeah, it's going to be Minority Report style pre-crime. Anyway, so I'm going to quickly code in an arrival, right? So we wanted to do the Hertz, and we wanted to do the RNAV. Zulu 26AR with curves. No, hang on. No, the 08, not the 26. This one. Sweet. And so what they want us to be is 13,000 at Elmham. And it's actually going to shorten up or move our descent further out, so that's helpful. Because right now, the airplane is not aware of where we want to end up. All it sees is Elmham is our final fix that we've got on the flight plan. And the way that the FMS is designed, it is targeting your descent by default, given your selected vertical path angle, which in our case, we go here, VNAV setup, and we'll go to the last page here. We've got a selected 3-degree descent path. You'll notice it wants us at Elmham at 3,400. Why is that? Well, in lieu of any other constraints for it to anchor the descent, it's going to take the last waypoint that it could find on the flight plan, which in this case is Elmham, and it's going to angle it in such a way such that a continued 3-degree descent is going to put us 1,500 feet above the destination airport at 10 miles. And yeah, that's essentially what it's targeting here. It's essentially 1,500 feet above field elevation, which is way low for Innsbruck. So we're gonna straighten it up a little bit. We know we're gonna be at Elmham at 13,000 here, so I could, in principle, just go ahead and punch in 13,000 here. Just be done with it. You'll see that moves the top of descent here. So without it, let's go ahead and let's reorganize this stuff a little bit. I'm gonna bring the range in. If I go ahead and punch in 13,000 at Elmham, I'm gonna move the top of descent quite a bit out here just before Zooey. I can leave that the way it is, so I'll just go ahead and execute that. Give the FMS a slightly better idea of what we're going to be doing vertically. And there you go. It's already initiated a turn. We're still almost 12 miles away from Lassat, but it's already starting the turn. It's sequenced onto the next leg because we are limited to 12.5 degrees of bank. We're in half bank mode. And at this kind of speed, that is the amount of turn, that's our turn radius. And the crosswind it also looks at the wind conditions and that kind of stuff. So yeah, there's a lot of angle. There's a lot of turn radius that we gotta account for in this shallow turn. That's why it started the turn quite early. It's allowed to turn up to 12 miles away from the waypoint at above 370 knots true airspeed. So we are definitely above 370 knots, so it's going to start to turn up to 12 miles away from the waypoint. More than, if we're flying below 370 knots, then it's going to start up to 7 miles out. Has 1,000 feet to go. Cancel the alert here. Actually, I could turn off the fasten seatbelt signs there. Not even going to bother switching to cruise thrust mode. Really makes no difference. So just roll the heading pre-selector onto the next one. That'll be about there. And it's trying to figure itself out how where our top of climb is gonna be. And actually, it's probably going to pull it back a little bit. when we're rounding out the turn. Did anyone ever find information about that Australian lateral navigation requirement? I don't think so. At least I didn't look into it seriously. And there we go. 200 feet, just about VLS cap. We're in a cruise. Airplane is going to automatically accelerate to Mach 0.8. Again, if you were flying this correctly, according to all the usage limitations, you wouldn't be on VNAV speed control here in Mach mode. But I coded it. I know it works correctly, so I'm not concerned. Yeah, in terms of how much time we got in cruise here, it's about 75 miles away, so not very much. So VLS, LNAV, good stuff. Everybody get the champagne out. CL650 pilot, I don't know if you've seen the new cabin. It's going to be in your build soon. Got the chunky seats up here and everything. And never mind that the screen is a little bit clipping through there. Oren's going to put that up closer to the wall once it's all done and good and stuff and proper. And it's not going to be for the initial release, guys, but eventually we do plan on making the seats fully articulated. So be able to put up the footrests and tilt the seat back and all that good stuff, and even move the seat around. Never mind the floating buttons here; those are going to be popped in correctly for release. And I got a follower, Milio 17 Echo. Welcome. So there we are. That's bugging us with the baked ale. That's going to be done. Professor Jedi, welcome aboard as well. Cup holders and stuff. It's going to be foldable, the table here. That baked day was also fixed. Oh yeah, I knew that you were gonna get to that pretty soon. It's not a super high priority to have on stream, but you guys know that the airplane's just getting better and better. With that, there's these small little details that makes all difference. Yeah. Ah, thank you, Emilio. So, coming up on 50 miles to the airport. How are my engines doing? Pretty well, I guess. What specific information are you looking for? Let's see. Legs. Actually, I want to go to perf. No, actually, we can go to perf and see our, if I take the charts off of here, I'm going to see our landing fuel's 34.8. Just want to see the debug pop up again. Sure. Left engine state. There you go. That's the left engine currently, how it's doing. Spinning at 6,900 RPM on a fan and 16,000 RPM in a core, which corresponds to these respective percentage speeds. And yeah, accessories are pulling out about 10 horsepower mechanically out of the core. And we are bleeding off about 0.65 pounds per second of air. iPad's really not doing all that much at cruise. It's doing quite a bit, but not as much. Well, I mean, it's actually providing the majority of the thrust here. Yes, the bypass in the official ratio. Here you go, hon. It's 6.2 to 1, if you want to know specifically. You know, where you have to pull it back to con cruise. No langers. This is not a FADEC engine, so what FMC is that? Rojo Dad, it's a Collins FMC 6200 unit, if you want to know. It's fairly similar to what you would know on it's fairly similar to what you would be familiar with on a Boeing, but it is or the Proline system. Yeah, 6200 is a subversion of the 6000 series. So the bypass duct is actually doing the majority of pushing here. The way that the bypass, the core and bypass ratio is computed is a little bit more complicated. It's basically, it's mostly based on mass flows. I was speaking on the Q&A. Yeah, Q400. Is it custom made? Yes, Roger that, it is. In fact, the only thing that X-Plane is giving us here is the aerodynamic model. That's about it. There's otherwise, essentially the model is completely isolated from X-Plane. And it's not just one FMC, it's 3 computers that are running in parallel, talking to each other. Well, this is currently sitting on the data link page, but yeah. The 3 FMCs are independent of each other. All the debug menus. Yeah, also got the ability to fail the crosstalk between the computers. We just were debugging that earlier today. So we can actually go in here and kill the crosstalk between all the 3 flight management computers. So if I bring this up like so we can see. Yeah, let's go like, I don't know, or something like that. And I go ahead and kill the crosstalk buses between them. Have a good one. Thanks for stopping by. So now if I go like this, you'll notice the change only appears on one of the flight management computers. And I can make an inconsistent flight plan between them. Cancel mod, cancel mod. Now I'm going to clear the fault. And it should reestablish crosstalk again and be happy. Now if I go and do an edit here, it propagates out to the others as well. Good stuff. It does actually, by the way it works, if you want to know, it's a little bit small to see for you guys, but the way it works is it basically kills the data buses between the airplane, between the FMCs. So if I go and kill the crosstalk here, basically sets the buses into a failed state. Well, you can't see it quite here, but it basically kills the data buses between the FMCs, and that causes them to lose all crosstalk capability. So what would happen if you had different flight plans on the FMCs suddenly have crosstalk again? They don't crosstalk the flight plan constantly. They only crosstalk it on a change and on a flight plan sequence event. So as long as you flew with disconnected flight plans, and then each of them would sequence on their own and try to navigate on their own, it actually would matter which of the 2 autopilots is flying. So currently this is flying on the right hand autopilot using the FMC number 2 as the master. If I swap it over, it's now left autopilot flying on the left FMC. So you better make sure that you know which one you're using if you've got a crosstalk failure. You can actually induce a crosstalk failure sort of manually, I guess, if you got inconsistent navigational databases between them. I will not let you swap them in flight, but on the ground you could. Coming up to top of descent here, I'm going to pre-select a lower altitude here to let the airplane descend. I'm actually going to let it go all the way down to 13,000. Going to be our initial approach altitude. I'm just going to quickly program in our approach here. So 34.8 is going to be our arrival weight. So go to approach. I'm actually going to go and fetch my data link stuff here. So weather. Gotta go terminal weather. LOWI, low E. Go ahead and send off the request. Yeah, right. We're VDL mode 2 over Europe, so that goes fast. We've got variable 2, few 4000, broken 1100, 4 degrees, QNH 1005. What's RE or RA? some sort of rain? I forgot. I don't know that code. Okay, coming up to top of drop there. VPath has captured. And down we go. Cool. So 1005 is the altimeter there. I'm just going to again use this guy as a pre-computer. 1005. Why are you rolling like this? Oh, right, yes. we're actually turning. That's why you're rolling. That kind of makes sense. Cool. So 10052968. So I'm just going to pre-select that up here. About there. It's 29567. Close enough. Doesn't have to be super, mega accurate. I'm looking at decoded METARs and aviation. It doesn't say what RERA is. Yeah, I've never seen that. Usually, I mean, the US, they have the tendency to put remarks, but you'll have a remark keyword here, and then they'll put various, like, station-specific remarks, like sea level pressure value, and blah, blah, blah. Recent rain. Ah, that's a new one. I'd never seen that one on a METAR decode. Every rain shower 20 minutes before the time of the observation. The moderate rain at the time of observation is coded RERA. Oh. Never seen that one code before. Oh, good to know. Cool. 1005, 4 degrees for the arrival. 4 degrees. I'm going to actually select an approach while we're here. RNAV Zulu 08 from LMM. Go and check if we got to close that. We got a disco there, but we can close that up. And that's all good. LMM, Whiskey India 749, and that matches with the arrival chart, hopefully. I'm going to execute that. We can go ahead and check it on the chart as well. So, just do a quick check. LMM 13,000, that is expected. 13, Whiskey India 749, 13 or above, good stuff. And speed. Then we got a speed of 175, a 3.6 degree constant angle descent. You'll notice this is now in large type. IKO. Oh, interesting. So there's a 0 degree descent between LMM and Whiskey India 749. That's expected. So this is flat segment here. 749 is our light path intercept as indicated by the Maltese cross here. And as a 3.6 descent with radius to fixed legs, so curved legs in between these 2 points. Or these 4 points actually, and we've got a maximum of 175. So you'll notice this is coded as a fixed angle descent. That's why these are in large type here. If they were predicted or implicitly computed angles, they are on small type. Large means database enter. 175, 175, 165, 165. That's for final descent, and that's all good. So over here, Whiskey India 749, I expect light path intercept is what we're going to get on the flight management or in the AFCS. So that's all good. For the minimums, RMP 0.3, 993 above field, so 2900 is our minimum. You'd also check that you can comply with climb gradients and that kind of stuff. I'm not going to bother. You guys are going to be the good pilots, and I'm going to be the idiot. So, roll you up to 2900. 2900, select. Good stuff. Barra minimums, select it. Okay, and so just check the routing, the rest of the routing anyway. 751, 752, 753, 754. Yes, that is correct. Runway 08, and then the mist. It says mist approach here. Whiskey India 103, 002, Rattenberg, and then hold at Rattenberg, flight level 95 or above. That checks. Minimum hold altitude of 9,500 feet. And we could also verify the hold here. I'm just going to quickly go in there. Rattenberg hold on the 045 is the outbound, so we're going to be 225 right turns, 1 minute leg time, and I'm going to switch to IKO hold speeds. It's not going to make a difference, but just in case it did, I could. So that's the approach brief completed. And I'm going to go into perf here. Approach performance. So we've got plus 4C at the field. It's definitely not 1013. It's going to be 1006 for the meter. Or 1005 actually. And for runway wind, it says it's variable 2 knots. What is that? Variable 2 knots, so we're going to put that as a 2 knot tailwind. So it's going to be T2 runway wind. And I'm not going to take the current weight. Instead, get rid of this push-in button. Instead, I'm going to take my predicted landing weight, which is over on the VNAV page. I'll get rid of the chart. 34.8 thousand pounds. So I'm just going to punch that in here. 34.8. Keep pushing the buttons in. 34.8. It's going to recompute. And so we need 2,900 feet actual landing distance. We could take wing and cal anti-ice. So let's go ahead and assume that. It's not actually going to change the VREF speeds here. It would affect our climb gradient. And are we actually going to be able to comply with the climb gradient requirements? Where is your misapproach climb gradient described? Transition altitude. Final approach course. Huh, they don't mention anything, so I'm assuming they're going to assume the default one, or standard one, which is 400 foot per nautical mile. And fortunately, the airplane says that our misapproach climb gradient, when engine inoperative, is going to be 591 foot per nautical mile. Means we're going to be able to comply with it. Structural weight limit is 38,000, and we're just limited by max landing weight, structural limit. So that's all good. Send it. And complete. Sweet. Realign heading here. I'm going to actually pre-select the barometric pressure. So that is 1005. This guy here ever got selected to 1005, so that's sweet. And the FMS should start decelerating soon. I'm also going to run the descent checklists.
Descent checklist. Shoulder harness.
Yes. Secure.
Passenger signs.
On.
Pressurization.
Yes, checked.
Fuel quantity and balance.
Fuel quantity is good.
FMS
and balance
landing data charts.
FMS is set. Landing data we have confirmed and set, and charts are already brought up, so that's all good.
Approach briefing
is completed.
VNAV transition flight level.
That one is actually, we pulled that out of the ATIS here. I don't think it's not a published thing in Austria. You actually get that over the ATIS. We can actually manually program one in if we wanted to. It says 180 currently. That is actually not correct for Austria. It's probably going to be more like 130. So as soon as we hit, basically hit LMM, I'm going to transition over to standard pressure, or to local barometer, which actually is going to put us a little below the 13,000. So I'm actually going to transition a little bit before that, so that we don't dip underneath 13,000 actual barometric altitude.
Descent checklist complete. In range checklist next.
Sweet. And for simplicity's sake, I'm actually going to punch in 210 at Whiskey India 749 for speed constraint. So the airplane starts decelerating. I actually wanted to decelerate more than that already. Let's just punch in 200. In range checklist. In range for what? In range of the, so for the in range flows, they just call them in range, in that you're within about a 40-mile range of the destination airport. Which we are currently. Just about getting there. Yeah, I'm gonna run the before in-range checks now.
In-range checklist. APU. Started. Altimeters.
Paradox, thanks for the follow. Welcome aboard. Altimeters, we're gonna go ahead and actually, you know what? We're gonna swap them over now.
3 set, cross-checked. Avionics.
Are set.
External lights. On. N1 target.
For the N1 target, for approach, you gotta swap over to TO or TGT.
Set.
Now it's waiting for the APU transition. Yeah, it wants us to decelerate like crazy here. I'm just gonna go ahead and pull a bunch of speed brake. Just about getting ready to level here at Elmem. I'm gonna go ahead and arm approach mode. I'm gonna assume that we're cleared for the approach. There we go, VGP capture. Funnily enough, it's captured VGP into Whiskey India 749, but it's a 0-degree descent, so it's basically gonna go vertical. It's gonna go VGP mode level for a little bit. You see it right now, it's going basically at a 0-degree glide path. It's just leveling, and as soon as it gets to Whiskey India 749, it's going to continue on down. No, in VGP mode it will not. That's going to pitch over a little bit harder. So, going to go flaps 20 to get the speed under control. Because otherwise we wouldn't be able to do a 3.6 degree fully idle descent at 13,000 feet. It just wouldn't happen. Flaps 20 is going to give us that. Cool beans. There we go. I'm still in managed speed, or FMS speed. RMP approach. So we are in glide path mode now. Now we're just waiting for
APU PAX transition.
There we go. Actually gonna pre-select 9.5, which is our missed approach altitude here, and you'll see it'll drive right on through.
Completed. APU generator. On. CAS.
Is check. We got nothing there. That's expected.
In range checklist complete. Before landing checklist next.
Yeah, that's it. There's nothing more to it. Basically, just push a bunch of buttons, and the airplane's gonna fly where you told it to. See, now it's starting to slow down, so it's starting to pull the speed target back, because there is a 175 speed constraint over at the next waypoint, which you can see if you bring up display menu here and you see say speed. Give me the speed and altitude constraints, if any. There's only a speed constraint there. And yeah, it did beep at me that we're approaching 9.5. That's just a reminder. If you set it up like that, you can just go ahead and cancel. It's not going to beep at you once you leave. So if you were in normal modes, something other than glide path or glide slope, if you deviate from your selected altitude by more than 200 feet, it'll beep at you once, and then once you pass more than 1,000 feet away, it'll beep at you again to tell you that, hey, you've done an altitude deviation. But you'll notice now, once I pass 9,300 down, it's not going to beep at me anymore, because we're in glide path mode. It expects us to leave. It expects us to go right through this pre-selector. It only beeped at me when I was approaching it within 1,000 feet to remind me that, hey, if you wanted this as a reminder, then here's your reminder. And pulling speed back nicely. And into the clouds, here we go. So I'm going to go ahead and fire up the engine anti-ice. Or Cal anti-ice. And into the clouds we go. Of course, you got synthetic vision, so kind of cheating. But yeah, we're doing cloud surfing a little bit. Just about. Just past the clouds there. Yeah, with synthetic vision, it's pretty hard to go wrong. As long as you get correct GPS position, of course. If this thing loses GPS position completely, then it's gonna go blank. I'm gonna tell you SBS inop. There we go, coming up to first turn. And watch the thing drive us right on down the line here. So we're gonna be 175 at that position here. And so 175 speed limit, and that's indeed where we are. 177, whatever, close enough. And I'm going to show you the prog page here, and it's going to show us what the cross-track deviation is and vertical deviation, if any. So we are within a foot of our vertical path and within less than 0.01 nautical miles of the lateral path. So it's essentially driving us. And by the way, if I pause it quickly here, 0.01 nautical miles, that's about the wingspan of the aircraft. So we are within one wingspan of the flight path and within a single foot on a vertical path. I'd call that, you know, pretty accurate steering. Oh no, 0.01 nautical miles left. 0.02, and it's gonna pull it back in. CL650, welcome, welcome. See it put the flight path vector a little bit to the right of the track here to pull us back onto the flight path. And you can also see the lateral CDI deviation went down to 0.3 nautical miles for final approach. So this is now 0.3 nautical miles. It's fairly sensitive down here. Just so you get extra awareness of any lateral displacement that you're going to be flying. Where's this pilot one? Thanks for follow. Welcome aboard. And we got some rain going. +4 TAT. We can go ahead and fire up the wing anti-ice. And we're flying below the wing anti-ice power limit. Normally you should be having the engines a little bit higher when you're warp speed. Yes, sir. Southern Controller, welcome. So many people joining in just as I'm getting ready to land. Appreciate you guys coming along. Yeah, we're in warp speed currently. I'm going to take over here. The next speed constraint is 165, and the FMS is going to start slowing down soon. I'm actually going to take it down to 160. I'm going to start configuring for final approach. I'm going to pull it back to 160 just by rolling the speed pre-selector. You take away control from the FMS, goes into blue speed bug there. See, and now the light actually does not come on straight away because that only comes on when the wing's sufficiently hot, and at low power we've been flying in cold air for quite a while. The wing's actually cold soaked now. So I'm going to go flaps 30 here. As we come up to the second turn here.
1,000. Terrain.
That's a little bit pissy about the fact that we're flying sort of into terrain here. Roll the speed all the way back. Flaps 45 and before landing checks.
Before landing checklist. Landing gear lever. Down indicating. Nose steer. Arm centered clear. Anti-skid.
Gonna do an anti-skid test.
Armed tested. Passenger signs. On. Wing cowl anti-ice.
That
Continuous ignition.
is
On. Thrust reversers. Armed. Spoilers. Stowed auto.
continue.
Flaps. Set. CAS.
Is checked.
Before landing checklist complete. After landing checklist next.
Cool. It's now my airplane. I'm going to leave the ATS in because I'm lazy like that. Zoom in a little bit so I can see a little bit better. And really it's just a matter of lining up that flight path vector with a little circle inside of it. That's your flight director target. Also looking very nicely on the pappies. 2 whites, 2 reds.
500.
Weapon is checked. A little bit went from the left. Not very much. A little bit low. Left to center line. 3 reds, don't want that.
100. 50. 40. 30. 20. 10.
A little bit there. Scared. Okay, speed brakes, thrust reverse. Alrighty, a little bit of brakes there. Manual braking. So the thrust reversers, and here we go. Sweet. So cancel the ATS errors there. That's because I pulled out the thrust reverse. Around the after landings here. Just as we vacate here.
After landing checklist. Landing pulse recog lights. Off. Anti-collision lights. Off. Continuous ignition. Off. Windshield heat. Off. Probes. Off. Wing anti-ice. Off. Cowl anti-ice.
I'm gonna leave those on.
Spoilers. Stowed. Flaps. 0. ATC TCAS.
I got a
Alt on. Radar mode. Standby. After landing checklist complete. Engine shutdown checklist next.
Cool. Brakes off, and we'll taxi to parking. I'm gonna leave the Cal anti-ice. Actually, oh no, what's the weather here? It's +4. We got rain. I'm gonna leave the Cal's on. And again, I didn't need to add power here. It just rolled away on its own. Right turn here. I don't know exactly how they park here, but I'm just going to sort of wing it. Sort of have them parking here. For funsies. So I can take the landing or taxi light out. I'm going to park right by the road. And walk over to VA terminal or whatever FBO they got here. Sweet beans. And let's roll a little bit forward. Obviously you have a marshal here to actually tell you how to park, but I'm an idiot. I'm gonna call it like this. Oh, shutdown checks.
Engine shutdown checklist. Taxi lights. Off. Parking brake. Set. Reverse thrust. Stowed. Generators 1 and 2. Off. Engine 2 shut down. Fuel boost pumps.
Gonna come off.
Off. Fuel system.
We're looking for a right fuel low pressure here. There it is.
Engine 1 shut down. Check ITT below 350 degrees Celsius.
There it is.
Anti-ice. Off. 14th stage. Off. Beacon. Off. No steer. Off. ATC TCAS.
Come here and punch in standby.
Standby. 0. Parking brake if chalked.
Yeah, I'm gonna say that we got the chocks in, so parking brake's gonna come off.
Passenger signs. Off. Cabin differential. 0 psi. Engine shutdown checklist complete. Securing checklist next.
It ramp size in its database. No, it doesn't. Cold stuff, unfortunately. This is just purely scenery stuff that you're seeing here. So X-Plane does not actually understand what sort of services we provide at the airport. Or not quite. It does have a little bit of meta info about the airport, not very much. Yeah, that was what you might call an arrival into an airport. Let's see what I did for the landing rate. Or deloads. 0.196. That's fairly good. It was a bit of a long landing. Could have been better. But yeah, that's a good delta G. That's a fairly low one. It did land a little bit long though, so had to then kind of help it out with a lot of thrusters. But there you go. It was actually, in terms of landing rate, it was not that good Pilsnerish. Oh, sorry, not landing rate was good, but in terms of landing, length, it was a bit of a floater. And I was kind of caught out by the fact that here in the X-Plane model for Innsbruck, I was kind of scared. Like I heard the radio altimeter come up real fast, so I kind of pulled a lot of nose up, and then I didn't realize that here in Innsbruck, right about past here, is actually a downward slope. So I was actually trying to catch up to the runway. Look at it like this, so you can clearly see that the runway actually slopes down, and so I was trying to catch up this part here. Whatever. Appreciate the readout on the panel. Yeah, that hill. We can go actually do a replay. It won't restore the avionics, but it will at least, give us sort of an idea. Visually what it looked like. Oh, yeah, it was this was basically... Can I stow this thing? I can't. Yeah, I was seeing this, got a bit of a sink there. I was pulling it up, and I got scared here a little bit, so flared hard. And then it started descending away from me, so. And I shut down the engines, so the engine sounds are now off. Anyway, so that's the situation. Anyway, glad you could join me, folks, here on the flight today. Pop the door open. Although now it's raining, so whatever. We'll leave the door closed. Oh, I mean, honestly, the airplane did most of the heavy lifting there, so I take credit for coding it, not really for flying it. So yeah, it did the flying part for me. I just did the coding part, which is really the part that I enjoy. I guess, I mean, I do enjoy flying, but it's kind of satisfying seeing your work actually not get completely lost. And I'm super happy about the fact that we've got a cabin. Yeah. I mean, Gordon's had the 3D model in his repos for months now. He just hasn't had time to, fully texture it up. But yeah, it's coming together, folks. It's coming together. It's starting to look like an airplane. I gotta make like these little screens here come on and everything. But yeah, it's coming together. It's starting to look like a business jet cabin. Yeah, he's got a slightly misaligned cup holders there, but those are going to be fixed soon. Yeah, it's going to be fun to fly in. So everybody, thanks for follows. Everybody for joining in, and just have to push. Yeah, I'm sure. There's no need to go crazy and hurry with everything, but I can't wait for you guys to be able to get your hands on this. Release is going to be before the year's out, so count on that. on your Christmas spending and everything. You know, all that good stuff. So, talk to you later, folks, and I'll just leave you with this shot here. Hey, everybody, take care. Love you all.